Well, hello and welcome to SkyTour LiveStream for today, December 2nd. Can you believe it? You know, I have some special guests with us tonight. As always, we have Daryl Mason. Hi there, Daryl. How are you?
Well, Mark, I'm good. How are you?
Thank you. I'm fine. And we also have
special guest.
Yes, hello, special guest. And that special guest is none other than SkyTour LiveStream benefactor and really good friend to us and host of her own show on KGRA, Marianne Robb, host of iDetective. Marianne, welcome to the show.
Well, thank you, Mark. It's so great to be here. Daryl, it's an honor to be with you tonight.
Well, this is great.
You're going to give me a big head.
You know what? It's okay, Daryl. You deserve to have one. You know, I've called you an astronomer's astronomer many times, and
stop doing that.
Always meant it. Look, there goes a satellite right through the field.
Sweet.
Boy, it was a beautiful bluebird day here today.
Wow.
Sunny, not a cloud in the sky. Got to 70 or 71. Just about perfect. Supposed to start changing tomorrow, though.
Well, let's see. You are in Colorado. So, being in Colorado, I guess you basically have to look at the weather and say, if you don't like the weather, wait a minute, right?
That's what they say.
Yeah, and they're true.
Where I am on the Front Range, it's a high desert, and I mean, we get like 15 inches of moisture a year. And if it wasn't for the altitude, it'd be a lot like Arizona, where Marianne is.
Yeah, and Marianne, how was your weather today?
Oh,
Go ahead.
I don't want to say that
you can say it.
Broke another record. It's been in the mid 80s. Bright sun, blue sky. And I think we're supposed to get down into the mid 70s by the end of the week.
All the way down to the mid 70s. Wow. Well, see, I can check because I have my focusing system up there, and the temperature inside the building out in the desert is 69 degrees. And it generally gets a little cooler out there than it does in the Mesa region where you are.
Yeah.
So, not bad, not bad.
Now, it's crazy how the temperature drops tremendously. Like this morning when I woke up, it was 41, 42 degrees. And by 11 o'clock, it was in the mid 70s already. It's just, it's amazing.
That's very cool.
Yeah.
Well, I want to welcome everybody to we have Vera Lucia Campos from Brazil. We have Carmen. Thanks for coming, Carmen. Haven't seen you in a while. Really glad you came back and checked us out. And then, of course, we have you, Daryl, and we have Farba was here. We have Do is here, Do W. We have Zadarak, who's here. Donald Kunzer. And we have Isabella from Bulgaria, and Daisy and Zoe with us. You know, it's like old home week, and here comes the satellite. It's going to hit me. I got to be careful. Look out. No, get away from me. Get. Oh, see, almost hit me. That's right. So it's so good to see you. And Don D is here with us. PG Petita, how are you? How's Pennsylvania tonight? I hope it's actually reasonable weather. It's been pretty cold up here in Connecticut. But, you know, the building is out in the middle of the Arizona desert, and we're running it from Connecticut. So I feel like I'm a little bit in the warm area. Hey there, Bernie Dodge. How you doing? Welcome from San Diego. I'm always checking out the San Diego cams. I love it out there. It's one of the only cities I like to go to that's, got a lot of things for everybody. Daryl, I think I cut you off before. Do you have something to say? I apologize.
I don't remember what I was saying, so I guess it doesn't matter.
All right.
It was to no import.
All right, well. Hey, Greggy Gilgan. What's
I'll
that?
be in San Diego tomorrow night for a couple of days.
That's why I was bringing it up, because Marianne will be in San Diego. She's going to head out there with her friends Alejandro and Karen.
Yep.
So it'll be a lot of fun. I won't be there, of course. I won't have a lot of fun. I'll be here in the cold in Connecticut, while you'll be out there in the warmth of San Diego.
Of course.
Yeah.
Be thinking about you guys, I promise.
I'm sure you will. Yeah. So, Oh, Don D. Sorry, he says perfect skies and no telescope. Sorry to hear that. But if you got a camera, you can put it on a tripod and aim it up. And if it's a regular 50mm lens, you could set it for 30 seconds or less and get a pretty nice shot. So you can try that. Even if you don't have a tripod, you can just lay it on its back and aim it straight up off a picnic table or any kind of a block of wood, and just take a time exposure and you'll get some good shots, believe it or not. So it's another wonderful night here at SkyTour LiveStream. We've got a beautiful night sky. Our night sky right now is, well, there's almost no clouds in the entire state of Arizona right now. That's pretty good considering we're kind of just left of center in Arizona. So for those who are just joining us, this is the telescope control system up there. That's the telescope in the building right over my head. And right here is the telescope computer. If I make that display light up, you can see the telescope it moved a little bit and the display goes on. That tells us a lot about what's going on in the telescope right there. And then this is the main view right here. And then of course we have this little slide out, okay, that's going to come out here. That is the camera control system. And we have our exposure time here. Right now it's set to 1000 ms, which is 1000 milliseconds, which is 1000 times 1 millisecond, which is a second. There's 1000 of them in a second. And so we go by seconds or milliseconds here. And then we have a gain, which is a sensitivity. Right now it's set to 325. That's a very, very high value. It goes up to about just under 600. So we're over halfway there, and it's measured in the thousands of ISO like a regular camera. So it's a very, very sensitive camera. So this is our setup. And then to find things, we actually have a planetarium system that you can see that right now our telescope is in the sky pointing here. And we don't know exactly where that is, other than the fact that it's right in the sky at that point. If we click on it, yeah, I know. I was just gonna say, if we click on it, right, Daryl, you know what we get? We get the coordinates, right? So there it goes, and then it tells us our right ascension and our declination. The right ascension is the left to right, measured in hours, 0 to 24, and the declination is plus 90 to minus 90 in degrees. So 0 to 24 hours being the number of hours in a day, basically. So that's where we are, and we're right near a bright star called Fomalhaut. Interestingly, we'll just check out Fomalhaut real quick because we won't see what I'd like you to see because it's certainly not something we can see. However, what we look at Fomalhaut is this is a star that actually has a debris disk around it. And this debris disk actually has a planet in formation, and maybe two. So over several years, there has been some photographs of this debris disk, and we can actually see the movement of a planet in that debris disk. Now, that debris disk is really, really far. It's as far away as the outer Kuiper belt on our solar system. And that puts it well over 60 to 100 astronomical units out. Considering we're 1 astronomical unit away, that's pretty far. Okay, so that's Fomalhaut. This here is not a debris disk. That's actually a artifact of the camera system because Fomalhaut is so bright. Okay, but one thing to note. Go ahead.
Star.
What's that?
Fomalhaut is a cool star. It's a bright star that sits all by itself down in the southern part of the sky this time of year. Mm-hmm. If you were to go out and look, it's to the lower left of Jupiter. You can't mistake it. It's all by itself down there.
Yeah.
I always call it Lonely in the South because it's by itself.
Yeah, that's cool. It's true.
It's in the constellation Pisces Austrinus, the southern fish. Mm-hmm. Carry on.
No, that's fair enough. I love it. So I'm just going to do like a 10-second photo here on Fomalhaut, and I'll show you why. We're not going to see any planetary structure or anything like that. But what I want to show you is what else there is. Now, Daryl said it's sitting there all lonely, and he's right. But the difference between lonely and not lonely is just an exposure away. All right. So you'll notice many more stars are in here. And again, this is just an artifact. But one thing to notice is that the more exposure we use, the longer that we expose, the more stars come out. And so tonight we're going to do some contrast. We're going to actually take photographs of areas of the sky that look kind of barren. And we'll do them for like 10 seconds. And then we'll do them for like 55 seconds. And you look at the incredible difference that you can see with just a little bit more power. So that's what we're going to do for tonight. We're going to hang out and do that kind of thing. We're going to take advantage of the fact that we don't have a moon to worry about. And the only thing we have to worry about are satellites. And we'll see probably, well, I don't know, Daryl, you and I saw at least 30 that one night that came through in a course of about 10 minutes, if I recall.
Mm-hmm.
Yeah.
Wow.
Yeah, I know, Marianne. That's a lot of them.
Well,
Okay.
There's a couple of showcase objects not too far from Fulmar Hut. If you want to look, they may not meet your qualifications for what you wanted to look at tonight.
No, that's fine. I mean, we could, if you're talking about, let me just bring up the structures that are out there. Are you talking about the helix?
That's one.
All right, there's the helix right there. And what was the other one? This galaxy right here, the Sculptor Galaxy, is that what it is?
253, yeah.
Yeah. Not sure.
253.
Yeah.
We've looked at it recently.
Yeah, that's great. That's a string of pearls. That's C72, Caldwell 72.
When you guys get a chance, I got a question for you.
Okay, there's a southern pinwheel, Daryl. We should look at that too. Don't you think?
Sure.
All right.
I don't know much about it.
I don't know if we'll see it though. Yeah, because we have to go down pretty low to see that. But first thing we'll do is we'll check this out because this is kind of cool. This guy right here. Right? And Marianne has a question.
Well, just the question is on Stellarium here, talking about the magnitude.
Yes.
Is the magnitude the lower the number, the brighter the object is, or is it the other way around?
No, that's exactly what it is. And not only that, you can go negative with magnitudes. You can have a negative magnitude, which is even brighter. The sun is like minus 26. The moon like minus 13, basically.
Yeah, if you see Venus right now over in the southwest, Venus is the brightest thing in the sky after the sun and the moon, and it's about magnitude minus 4.8 the last I saw. Maybe brighter than that now.
Yeah, and Jupiter's
It's
like
pretty bright.
Jupiter's like magnitude minus 2.
Yeah.
You know, just over minus 2. So there's a lot of cool things, you know. So that said, let me remove this message for now. Okay, so let's go to the Helix Nebula. This place we're going to go to now is the remnant of a star that has long since died, and it left behind basically the innards of the star that have been dispersed to the interstellar medium. It's really quite an amazing location. So when we go check it out, I'll go on our system here and get rid of the stack, because we do not want to stack anything right now because we're moving our scope. And then we're going to come by and do this. This is a hyper process mode where we can actually see everything that we're looking at and where we're going. So right now, the telescope is centering on a star called SKAT, S-K-A-T. And then you'll see a fuzzy thing right here. That fuzzy thing moving into view is actually this nebula, the remains of this dead star. It's called a planetary nebula because when you look at these, you can mistake them for a planet if you looked at them in a telescope, a small telescope. This one, on the other hand, is quite large. It's somewhat large in the sky. Give you an idea. Our view here, if we look across the view here, and I'll just get rid of the camera view over there for a moment. From here to here is 4 full moons across. Okay, and from here to here is 1.5. So this is just basically a little under the size of a full moon. Okay, so that's a big object in the sky. In a small telescope, you wouldn't even see it, as a matter of fact. So I think that's kind of interesting as well. And what we're going to do is we're going to move the telescope a little bit this way. Let's center this object up.
If you looked at it in a small telescope, relatively small, you might see something, but not very much. It's big, but it's dim.
Yeah, and that's why it's so dim, is because it's so big. If we looked at the same thing 4 times as far, it would be a lot brighter. It would appear that bright, because the brightness is condensed into a smaller and smaller area. And the smaller the area, the more your eyes can detect the light coming from it. So anyway, so here is the nebula. Now, why don't we actually just take a nice photo of it? We'll do two or several 25-second photos of it, and you'll get to see the extent of it. It's really quite beautiful. Okay, and it may look like it's going away, but I'm just taking us to a stack view, and I will clear what we have in there now. That was Fomalhaut earlier. And this bar across the bottom will tell us when this exposure is done. It's called a progress bar. You can see the telescope in the building right there, aiming up into the southern sky. And here comes the first exposure. Look at that.
Oh, wow.
Yeah, it's really pretty.
Very nice.
Let's just get the color rendering right. And let's drop our sky background just a little bit. Okay. And now, let's actually... We'll do this first. We're going to pin this so we have it there. And now we can do this. Maximize it. Alright. Not only that, alright, and we got one stacked. We're about to get a second one stacked. We're going to go up to... we're actually at a much smaller size. The full size, if you look at the full frame, here's how big that full frame is. Ready? That's how big the full frame is. So it goes outside this view and out above and below this view quite a lot. We have a little bit of a guiding error, as you can see, teardrop shapes, and that means that we have to just play a little bit with our guiding system, and I haven't done that, so I will do that.
Now, Mark,
yes,
I think you showed this the other night on a stream.
Yeah.
Did you explain it all? It looks like there's red all around the outside of it. Is that just something? Okay, is that a camera problem, or is that actually out there? No,
that's actually there. See, when the star, this is the star right there. That's the remains of the star. That's a white dwarf. You'll notice that its color is markedly different from the stars around it. The reason for that is because it's extremely hot. Hotter objects in the universe are bluer in color. This is the remains of the core of a previous star that's been contracted down. It's no longer doing nuclear fusion. It's actually just has all this pent-up heat that it's stored in there for billions of years from the fusion processes. And the outer layers of the star blew off in a very gentle manner, kind of like sloughing off outer layers as the star had expanded and contracted. It did some puffing, basically. And it puffed off its outer layers like this. And among them is hydrogen gas. Among them is oxygen. Now, why am I going like this around the oxygen, around the hydrogen with what's red, and why am I doing this around the oxygen, which is green? Well, the reason is because the star is so hot, it has a lot of energy that's going out in the ultraviolet range. Ultraviolet energy is extremely energetic energy that will affect the atoms in a gas. So we have this gas out here of different kinds of elements, okay, because elements are made in the hearts of stars, and stars are made with those elements in their atmosphere. This star was more about the size of our sun. This was not a supernova. This was just a gentle puffing off of its outer layers as it died. That's what our sun will do. And the red is hydrogen gas that has been affected by this white dwarf. It's been made so hot that the electrons leave the atom, making just a hydrogen nucleus, and then they rejoin the atom and give off red light. And the same thing happens with oxygen. So this is a ionized hydrogen color, and this green is a doubly ionized, meaning 2 electrons get bumped off for a period of time, doubly ionized oxygen over here. So the green is blue is oxygen, and this reddish area is hydrogen, and on occasion neon. So there's a lot of materials in this nebula that we could see, and all of it is stuff that goes in our periodic table. And that periodic table, of course, all of it was made in the hearts of stars.
Yeah. And I also see there's more red kind of even expanded even further out. Yeah, right in there.
Yeah, that's wow. And there's some over here too. And we only did a 25-second shot. In the more deep shots that we've done, it shows even more. But let me back out a little bit here. Okay. Because I said I didn't like the fact that our telescope had not been guiding correctly, and so I'm going to just fix that right now. I'm going to go into our guider and drop down. You can see the menu changing right here, and I'm going to change our rate of guiding to this. Let's do this. Okay. And then we're going to go up one, and we're going to change our rate of guiding here to 0.5 because the other was too aggressive. Okay. So now, if we clear this and we allow this next one to come in, we see the next one's about to come in. Maybe it'll come in right now. Okay, we just missed it. That's okay. All right, so in 25 seconds, we'll see the second one, this next one. And I'm going to predict that this one is not going to have teardrop-shaped stars. It's going to be more round. We have to wait a total of like 11 to 12 seconds for the telescope to get a guide star. And that's what we're going to do. Oh, look at that. Got a satellite in part.
Yep.
And you can see the stars are a lot sharper now. And Do has a question. Marks, looks like some helium in there too because there's a bit of blue. Well, actually, that's a very good observation. Do, I'm sure that there is some helium out here. But the dominant species, if you want to call it that, of atom out here this is oxygen. It's called oxygen 3. That's the O, like for oxygen, and then the Roman numeral 3, I. And that's just the double ionized oxygen notation. Okay. Hello, Susan Woodcarver. Good to see you. Thank you for coming. Very nice to have you. Okay, hi there, Stars Are. Yeah, go ahead, Daryl.
Is the green, the oxygen, being closer to the white dwarf, and the hydrogen, the red, being farther out? Does that mean that they were released at different times? The hydrogen first and the oxygen? Are that different layers peeling off?
That's a good question, and I don't know the evolutionary and chronological structure of the helix, but different nebulae do different things at different times. So I don't know the helix in particular, but when you see the outside, what Daryl's suggesting is that maybe this red came off first, and he's right, but this red here came off before all that, because it's farther from the star. I know you know that, Daryl. I was just explaining for everybody watching. And then there's a more red out here that you can't see because we're only doing a 25-second exposure, but you can see it out there too. And so, it's likely that was hydrogen. It's likely this is also hydrogen, and it's likely that hydrogen was in the outer layers. Now, the oxygen and the hydrogen are not stratified in a star's atmosphere, so you only have, say, hydrogen in one spot, then oxygen in another, helium in another. There is mixing going on, especially in the late stages of a star's life. You get something called dredge up, where the stuff from the core starts literally coming up and getting mixed into the upper atmosphere of the star. And there's multiple dredging things that happen when a star is evolving and going down that path. So I'm not sure about the helix, but I think also that there is definitely a concentration of hydrogen here and a concentration of oxygen here. So we'll check that out. That's a good question. I'll find the answer to that.
I would wonder, even if the hydrogen and the oxygen came off at about the same time, maybe because hydrogen is lighter than oxygen, whatever stellar wind might be going might have pushed it farther.
That's also a logical thought as well. Maybe the stellar wind from this dwarf has pushed the hydrogen past the oxygen, and maybe that's why we see the structure like this. But we also see other planetary nebulae like this that do not show this type of behavior. They don't have a core filled with an oxygen view, oxygen stuff. Like the Dumbbell Nebula has a strange hourglass shape, and we know that we have oxygen 3 in there, right? Yeah. And we have some hydrogen on the outside of that as well. But we also have a spike of something else that looks like it could be hydrogen or possibly neon that's going down in a line. So, and what caused that structure, you know? Then we have the Ring Nebula. Okay, and the Ring Nebula is another one where we don't have that central area that's filled like this the same way. So it's a little bit, they're all different, and there's different reasons for why each of them happen. And the helix, I simply do not know the chronological history of the helix, and I'd have to look up if there was any studies done to show where that comes from and why. But it is, again, the star is puffing off those outer layers. So in one of the more recent layers, obviously, we had oxygen. But could it be, as Daryl points out, that the hydrogen being lighter kind of outsped the outflowing oxygen? And maybe they were all puffed off at the same time, but because the oxygen is heavier, maybe, or more massive, I should say, maybe it wasn't subject to the stellar wind the same way the hydrogen was. That's very possible. That's very possible.
I know when we look at the dumbbell that, you know, it's that O3 color.
Yes.
And then we see the red that sort of makes like the apple skin on the apple core, you know, around the edges.
Around the outside, yeah.
Yeah, and if that's hydrogen, of course we wonder if that one might be neon also.
Yeah, well, there will be a mix in there, you know, and that's the thing about these nebulae. They have more than just oxygen, more than just hydrogen. This looks actually rather pretty, doesn't it?
Very.
That looks really nice. And we're at
looks like you nailed the tracking too.
Yeah, we got the tracking down. I had to readjust that, so I did. Yeah. And let's go to 100%. Let's go to 100% of frame and see what it looks like. Wow, look at that. That doesn't look bad at all.
Oh.
Yeah, and the focus looks good. What's that, Daryl?
Again, we're seeing some details in the clouds, like down at around 6 to 9 o'clock in particular.
Here, yeah.
Yeah, and farther out. In the same,
and then look at these radials here. These are beautiful. Look at this satellite right there. Another satellite right here. Oh, yeah. That's a nice thing. The longer we expose, the more those satellite trails automatically get removed. So here we go. So that's pretty cool. Now you can, but here you can clearly see the difference in the color between this white dwarf star in the middle and the stars around it. It's the hottest star in this image right here. Without question. It's the hottest star. That's pretty cool. That's nice. I did some 1 minute exposures the other night, and actually this one seems to be better. Seems to be better. Wow.
Pretty.
Yeah, it's really pretty.
Lots of fine detail in there that we're right on the edge of. All the way around inside that gas shell, actually.
Yeah, look at this radial. See these radial streaks here? You can see these radial streaks. There's one right here, one right here.
Yep.
Yeah, and those are all the outflow streaks. There's some here. This is an oddball right there. And I'm not sure why that's there, but it's probably tied to this complexity in here.
I've always wondered if that isn't like, sort of like you're looking down on a lawn sprinkler from above, and if that might signify the spinning of the white dwarf star itself as it was releasing the shells of gas.
Yeah, there's certainly that. Like when you see rocket launches that go out of control, you do see a spiral develop in the exhaust, and that's something that would leave and be preserved in space if it was gas from a star that's being ionized. It would that spiral would also be preserved. Starzar says he sees 2 shades of green. That's true. I think that it depends on the density of the gas we're looking at. Star. If we look here, we're looking at a lower density, for instance, than over here. And as we get closer to here, we're also starting to mix with other elements. And so the color of the green is going to change because we're getting a color addition from this yellowish red hydrogen gas or neon, or we could be looking at hydrogen beta in here. So there's a lot of different reasons why that can be. But it is all oxygen in here that we're seeing here. So it's pretty cool. That's a very good observation, by the way.
Somebody wants to know if you can do this in ultraviolet colors.
That's actually a very good question, because this is mostly in ultraviolet. This star is giving off a lot of its energy in the ultraviolet. So to do a UV analysis, we would have to be above the atmosphere, because we would like to see the UV unfettered by our atmosphere in the same way we'd like to see the infrared at the other end, unfettered by our atmosphere. So we wouldn't be able to do a really adequate UV study from here. And in general, the camera doesn't show UV anyway.
Yeah, what you are seeing, the green and the red, I mean, that is the emission caused by the ultraviolet light, and the emission we're seeing is invisible wavelengths, of course.
Right, and we can't see the invisible ultraviolet radiation that's causing the emission to happen. So that's and I'm always taken by this. If you look at this dwarf, right at the dwarf, just focus on that. You can see real cool details in here, because you're catching it with your side, the side of your vision, the averted vision. The edge of your retina is capturing more details. You can see these linear lines right here. This is actually quite a nice image. I'm really quite surprised at how beautiful this looks tonight. Must be a stunning night out there. I wasn't planning on taking a picture of this tonight or capturing imagery of it. But we're just going to take this, we're going to take our black level down just a tad more.
Ooh.
Yeah.
I like that.
I figured you would.
That's very vibrant, that red. Wow.
Thank you, Star. That's good. Hey there, Mind Remote. How are you? Yes, this is the Helix Nebula. And there's not a whole lot of stars that look like this. This is a dead star. You're looking at the white dwarf in here, Mind Remote. And it's blue because it's so hot and giving off that ultraviolet energy. So most of its energy is up in the blue end of the spectrum. so the star itself will look blue visually. But this is just a beautiful nebula, and it's actually quite large. Daryl, you're a font of knowledge on this. Do you know the size of the? I could go look. The actual size of the helix in terms of its size across. I can find it.
Oh, not offhand. I can find it though. Hang on.
No, I got it. I'll get it right here. It's 25 minutes of arc. It's called. So basically, that's a quarter of a degree. Not a quarter of a degree, but it's almost half a degree. It's just less than half a degree. Okay, so it's just under a full moon in size, as I mentioned earlier. It's 25 minutes, and the moon is 30 minutes in diameter of arc.
One thing people might like to know or to keep in mind, like when we look at the central star in the helix.
Yeah.
As Mark said, it's a white dwarf, and that central star, imagine what is left of the original progenitor star, if it was still like a solar mass, but it's been compressed down to an object comparable in size to the Earth.
Yeah, exactly, yeah.
It's very small, but it's very bright. And then when you compare that to other nebulas we've seen, like the Crab, where we can actually see the neutron star in the center of it, that Crab is a good-sized star shrunk down to the size of, say, Manhattan Island. So
right,
much smaller even then, and much more dense.
Exactly.
It's like millions of tons per billions or trillions of tons per teaspoonful.
Yeah. And Daryl's speaking, of course, of stars that are formed in quite a different way than this one here is. This one was formed by the contraction of the core of the star once it fluffed off its outer layers. All right, and that star is held up by its own pressure that it generates by how compact the matter is in its core, and that keeps it in that one piece. If you add mass to it, however, let's say there was a binary star orbiting this, and this star then was sucking in mass onto its surface, the star could end up becoming bigger than a certain mass, and that there's a certain mass number beyond which this star won't exist as a white dwarf anymore. It'll go to one of two fates. It'll become a neutron star and collapse even further, or it'll be entirely destroyed. Or the hydrogen that gathers on its surface can flash and fuse all at once, causing a gigantic explosion that we call a nova. Not a supernova, but a nova. And that'd be if there were two stars there. So there's a number of fates that the universe holds in store for objects like this. Now, if there's no star orbiting this, like there isn't in this case, then this one will cool eventually and become what we call a black dwarf. Black only because it won't be able to be seen, and it won't be giving off most importantly, any thermal or heat signature. So it'll just be cold and dank. So that's that, Hey Charlotte, I want to say hi. I said hi, but thank you. I'm glad that you lurk, and I'm glad you took time to chat tonight. Thank you. Good to have you with us. And then,
yeah.
Let me
Mark,
just say one
can I
thing,
ask a
Mary.
quick question?
Yes, go ahead.
I'm sorry. Well, you're saying that a star that orbits the center, the star, this white dwarf.
Yeah, if
is
we
what
had
you're talking about, right?
If we had such
How
a thing
would you-
happening.
Okay, how would you know that there would be, like other nebulas, that there is a star that is orbiting around it? Because you got so many stars all around. How would you know about that one star that's orbiting?
Well, in most of the cases, when you have such a condition where you have stars so close to each other that you can't distinguish them, they're called spectroscopic binaries, and the only reason that you can tell them apart is because you do what the name suggests. You take their spectrum, and you see two spectrums in your results. And if those vary at all, it means that like one star is going in front of another, and then this star's spectrum is what you'll see. Then as they come apart to here, you see both spectrums, and then as this one comes in, you see this spectrum. and then back, and you'll see the spectral signatures vary over time, and that will tell you that you're looking at a spectroscopic binary. Sometimes you'll have two sets of lines in a spectrum because we identify the stars by their spectra, and these dark lines called absorption lines that occur because of the relatively cooler gas in the outside absorbing energy from the hot energy being generated from the core. And those spectral lines could look like they're doubled up, and we know, for instance, the position of lines in a certain star spectrum. We know, for instance, I'll give you an example where calcium lines are. There's an H and a K line of calcium. There's a position in the spectrum where those two lines are right next to each other and appear. But if you also had a second spectrum superimposed and you had muddy lines, then you'd say, wait a minute, why are we seeing muddy lines? Why are these lines so broad? All right, and that would indicate that maybe you're looking at two spectra overlaid. Okay, and then if sometimes those lines get very clear, and then at other times those lines get muddy again, it shows that we're getting this going on where the stars are orbiting each other. And so that's how we know. When we can't see it, we can detect it by looking at the spectra, and that's again called a spectroscopic binary. Yeah, I know that's kind of a long explanation, but if you think about it, it's worth it to understand what's going on in these nebulae. This is really coming out good. I'm surprised. We've done 44 images stacked here, by the way, guys. 44. And what do I mean by stack? We take an image, all right? We take another image. We align them so they're lined up exactly. All the stars lined up. And we put that data on top. And we just do that over and over and over and over again. So the sandwich of images we have at the end has all the data we want to see, like this beautiful red color and the star data and the very, very delicate clouds in here. And the stuff we don't want to see, like the black of space, the noise that you have in there is muddied out and averaged out. And that's exactly what we're seeing here. Hey there, Jeremy Blaine. Believe it or not, I was thinking about Comet Leonard. We'd have to be doing a stream around 5 in the morning or 4 in the morning right now to see it. But we can go to a website to find out when it'll be in our evening sky, and I think it's going to be like right after sunset, Daryl. When's that starting? I think that's
later in December.
Yeah.
The latter part of December.
Yeah, and then we'll see it like right after sunset.
If you see Venus in the southwest after sunset, well, by late in the month, Venus is going to be a good bit lower, but the comet is going to be over in the same general area as Venus is now.
Mm-hmm. So that'll be really pretty, and we'll do that. And so, yes, Jeremy, we are going to do a Comet Leonard stream, okay? Because we want to do that. We want to see Comet Leonard.
I'm just amazed as the stacking continues, as you said, 44 plus images now that how that detail, 48, how the fine detail is building up in those clouds.
I know, and I'm just letting it go because it might make a, again, image that I wasn't even sure I wanted to do tonight. It reminds me of something I learned a long time ago when I was teaching science in a science center, and that is the serendipitous things, the things that happen by accident, serendipity. Here was an accidental exposure, not intending to go very long, and now what we got is a spectacular image forming right before us, and it could end up being the best one we've ever taken of this nebula. So it's pretty cool.
There's some fine little feather-like structures down around 6 o'clock.
I see here.
Yes, in that inner ring as well.
Then here, see these radials?
Yep.
Yeah, look at that. And we know those radials are really there. I've seen those. One thing that we won't probably be able to see are the little beads at the end of these radials. There's these tiny areas at the end of these radials that are part of the evaporative thing going on. So I think that'll be something to try for eventually, but not with this particular telescope. We're actually, again, let's show you the full view. We're looking. This is actually 137%. Okay, we're not even at 100%. We're oversized right now. If we go to the size of the actual image, then this is where we are. Okay, that's the full size of the image. Okay, in other words, if we go to one-to-one size on the screen, that's how big the image is, and it goes way far out on all directions. All right, so I'll show you how far if we go and we do like a fit to the screen type of view. Okay, we do here. We say auto. Now watch. Look how small that thing is. And this is our full view. 4 full moons, 3 full moons. Okay, so that's pretty darn nice. You know. And let's try something crazy. Let's actually go to 200% and see what that looks like. Okay, look at that. Look at it. It supports the detail right here. This is sort of unprecedented. I look at the detail right here. There's something really interesting going on right there. Right there.
You're on the verge of pixelating, but yes.
Oh yeah, I sure am. You know, that horizontal line isn't really there. That's actually just a artifact of the scrolling. So not a problem. Wow. That's really cool.
It is. That's something.
Wow. All right. Well, let's drop down and now here's the other part of this SkyTour LiveStream, guys. What we do is we actually will now take this. We're going to pause this stack, which, by the way, we're at 55 stacked images. Okay, and now that I've paused it, we're going to save. And if you look across the top, you're going to see it was saved in a file format. That file format is .fits. That's an astronomical format, and you might say, oh, well, I can't see that. And you're probably right. But there are some free FITS viewers. This is an astronomical file format. There's some free FITS viewers online that you can get. But if you don't want those, don't even worry about it, because we can do something else for you. One thing I'll do right now is I'm going to just reduce the black level just a bit to brighten this up just a bit. Okay, and now what I'll do is I'm going to save this exactly as we see it. All right, so now you have the astronomical format stack. That's the sandwich I was telling you about. And then this is the stack in terms of one singular image that's already processed to look cool. So you get all of it. You'll get all of that here. All right, and so that's the kind of thing that we like to do for everybody. We like to make sure that everybody enjoys this stuff. All right, and so there's something for everybody.
And there's the link over in chat for the server where you're storing your images.
Thank you.
Thanks, Daryl. Perfect.
Because, yeah, so this is the Helix Nebula, and there it is right there. And so what we're doing, the whole point here, of what we're doing here is, as these photos are being taken, when I do these saves that you saw up there, the save of the FITS file and then that PNG file, which, by the way, any graphics program will open a PNG file these days. You'll see this. And then you can zoom in and have fun with it. However, it's going up to a server that we've made available to all of you. It's a free server. That was the link that Daryl put in the chat. Thank you, Daryl. And you go there and you dig through. You'll see today's date. All right. And you can dig in there and you'll see different directories in there. Now, once I get in there after the stream, I'm going to rename them to the objects that they are, so you don't have any mystery. It'll just be a cryptic date indicator. But if you go in, you'll check it out. All right. So have fun and enjoy those pictures, and we'll look at some more things here shortly. Jeremy Blaine has a question. A lot of talk about so-called Planet X being detected and now have found its location. What's your take? Well, okay. The truth about that, Jeremy, is that we really don't know exactly where Planet X might be. But there is no doubt that we could have a large object that's orbiting, not heading for us, but orbiting out in the Kuiper belt. See, you know how we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto. I think Pluto's a planet, so don't get me started on that. Pluto's a planet.
Damn straight.
Damn straight.
Oh,
Yeah.
it is.
Yeah. The founder of
One thing,
Pluto.
though,
Yeah.
the Planet 9 versus Planet 10 thing. Uh, some legitimate scientists, they tend to call this mystery planet Planet 9 because Pluto has been downgraded from full planetary status. Whereas if you still call it Planet 10, some people think they're talking about Nibiru and all that stuff.
Yes.
So some people differentiate between Planet 9 and Planet 10.
Yeah. And we accept the International Astronomical Union's pronouncement that Pluto is no longer a planet. I actually met and sat with the guy who found Pluto, Clyde Tombaugh. And he was a very, very old man when I met him. And we were sitting on a grassy hill in Stellafane, Vermont. And he was about to do a talk. Well, I wasn't doing a talk at that point. And I sat there and I asked him about Pluto. We talked about the find, and he explained. And even then, he was probably in his mid-80s at the time. Even then, Clyde had this excitement about this find. And he talked about it like it was the most amazing thing. I couldn't believe what I was seeing. And it literally, and he filled you with the same sense of surprise and wonder that he had when he found it. It was really, really a good time. I really enjoyed meeting the man. But as far as Planet X, Planet 9, Planet 10, I think that we have to differentiate between what might be out there in the Kuiper Belt. I just mentioned all the planets, but beyond Neptune and Pluto, we have the Kuiper Belt. That's Kuiper, pronounced Kuiper. People sometimes will mispronounce it, Kuiper or Cooper. It's Kuiper. Well, the Kuiper Belt is a large horizontal belt of icy objects out beyond all the planets of our solar system. And then there is another band of icy objects beyond that called the Oort. It's not the Oort cloud, but it's the Oort belt. And then there's an Oort cloud, which is a more of a spherical bunch of icy bodies that is generally thought to have been where comets came from. We now know that some of that might still be true, but for a lot of this, we get objects from what are called SDOs, scattered disk objects, which are out there on the outer solar system, out beyond Saturn and kind of before Pluto. There's a bunch of objects out there that are in very highly elliptical orbits, and we get those too. So, but the Planet 10, Planet 9, Planet X, okay, these are in established orbits that are out in that Kuiper Belt, so they're orbiting. They're not coming in and doing this, and they're actually in established orbits with some of the other icy bodies out there. So there's some research that seems to indicate that maybe every several tens of millions of years there's a major extinction event, and it might be related to this very highly elliptical planet moving into the inner solar system or whatever. But there hasn't been any real evidence for that. So none actually that passes the tests that we expect to have tested. So I'm not sure if that's actually there or not. But my mind is open to the possibility that there's stuff out there we certainly don't know, because there is. We never expected an interstellar asteroid, but we got it with Oumuamua, messenger from afar, in Hawaiian, and that's the asteroid that Avi Loeb, Harvard Smithsonian astrophysicist, had mentioned in his book Extraterrestrial. Avi and I have done a lot of work together here and there, and I think that I've never worked with him professionally, but I've worked with him, on TV shows and things like that. And I understand, as he does, that we can't close this book on extraterrestrial possibilities, extraterrestrial life. He didn't say that Oumuamua was alien life. What he said was, we can't ignore the possibility that it could be. That's all he ever said. And he came under withering fire from colleagues. See? And I also don't care. I don't care. I have a very thick skin, so I don't care what people say. That's just me, though. So whether Planet X, Planet 9, Planet 10, whether that's actually a real body or not, there's some thoughts that maybe we have to look for those things, and my mind is open to them. But so far, we don't see any effects on our solar system, Jupiter most especially, from such a thing.
Well, that's the whole Nibiru thing. If there's legitimate Planet X, Planet 9, whatever you want to call it, they're saying right now they think it may mass 4 or 5 times the Earth's mass. If it was Nibiru, that's when you get into like, they say it's a dark star or something that's going to fly into the solar system and disrupt the solar system. All the planets are going to fly off into space.
Yeah,
that's when it gets silly.
Yeah, well, that's because people don't recognize the history. We've had this solar system in place with stability for billions upon billions of years. So there's no reason it's gonna head off into, oblivion now. So. Stars are asked a question: what is a planetoid? That's a very good question. A planet is a planet. You understand? A planet is an object of a certain size. It can say hold its own atmosphere, and we have a size limitation. Under that size, we can say planetoid. We can say asteroid, and so forth. And that's so the definitions of planetoid and asteroid are nearly the same, and so I think that all that's important to understand there is that when we talk about asteroids, okay, the largest asteroid is the asteroid series, and now they're called dwarf planets, as opposed, again, nomenclature change. What can I say? It used to be an asteroid, now it's a dwarf planet. Pluto's now a dwarf planet. Go figure. Us astronomers, we love to confuse you. And I don't agree with all of it, to be honest with you.
Astronomers, they can be just as prideful as anybody else. I mean, jealousy goes on and all the human emotions, and
That's
I
right.
dare say there are people out there that love nothing better than to tear Clyde Tombaugh down. Heck with them, that's what I say.
Yeah, that's fine. I get that. And now that he's passed away for many years, there's people out there that, feel now empowered to come out of the closet and start screaming,
Yeah. Thank you for humoring me with the helix mark. That was very nice.
I think it was a great thing to do. It turned out to be a very serendipitous, beautiful object to look at tonight.
Well, we're in that part of the sky.
Yeah.
You want to do NGC 253 while we're in the neighborhood?
Yeah, I was just trying to find that. I'm going to just do it again. I'll just go here. I'll find out where it's actually located, see how high it is. This is a beautiful object, guys. You're going to like this one, too. And what is NGC 253? It's a galaxy.
It's over to the left of, east of Omaha.
Yeah. Yeah. Okay.
Just below Tifda.
Yep. And we're going to go there now, and we're going to go... the star... Actually, there's another galactic... we have another chain here, right? Chain of galaxies, the Burbage chain here. So we might want to check those out later, too. Because those are cool. All right. Anyway, let's go. We'll check this out. We're going to go probably to the star Dipta, which is that in Sculptor?
Dipta's in Cetus.
Cetus
The
just
whale.
above it. Yeah.
Yeah.
Okay. So the way the telescope works is, if you look right there, you can see it says high precision slewing. It's actually going over to a star, and it's probably going to be going to Dipta, because that's what's near this object. So it finds a star near the object. There it is. Yeah, see, it's auto-centering Dipta, and it's going to center it up, and then I could put my pointer right where it centers up, and that's where the galaxy is going to be when it goes to it. So let's just see where it ends up, and you'll see what I mean. Okay, so it's moving there, and then right there. All right, now watch. Now watch at the end of that pointer. Okay, we got close. Let's see if it moves it in. Not bad. That's pretty good. So right there we have this galaxy. I think this is going to be another beautiful view tonight. Because this is really pretty. You know. Because we're 30 degrees above the horizon right now with our telescope. So let's go over here. And what I'll
you're
do
facing
now,
south? I'm
Yeah, if
kind
you
of
look-
looking at stellarium while you guys are doing all this too.
okay, well, if that's correct, we're facing a little more towards southeast.
Southeast.
Okay, maybe not. Maybe it could be about south. Yeah, and if you look, okay, right here, all right there, that's the telescope in the building, and that back wall that you see there, that far wall, that back wall, that's toward the north. The wall to that side is that you see there, that's to the east. This wall here that you can't see, that the camera's mounted on, that's toward the south. Okay, and then this wall's to the west. Okay, the wall over there that you can't see, it's to the west. So I waited the obligatory 11 to 12 seconds to get our guide star, and then I'm going to do a 35-second exposure of this object here. And because we're on our hypered view, like our magnified night vision finder view, basically, I'm going to kill that and bring us into our stacking program, where I will have to remove the last object. All right, we saved it, remember, and it'll be up at our server. It's probably already up there. So if you go to that server link, you're going to find that. Make a bookmark of that, so you can always check out the bookmark that, always check out the server and make sure that there's nothing up there.
Yeah, for me, Mark, DIFTA is right on the meridian. So for you, you're about a half-hour sky time behind me, so it's still slightly east of the meridian.
Right. And Starzar says south-southeast, and he's exactly right.
Yeah.
So here we see a satellite coming through the scene here. This is the galaxy. And we've done a one stack so far. And we're going to do some more. And then let's move in a little bit. Let's go to 75% full frame. And now you can actually see some really interesting stuff here. And the focus looks pretty good. Let's move over. And then bring it in. Oh, there we go. Great music for a galaxy, don't you think?
Beautiful.
Wow.
There's another neat galaxy over at the far end of Cetus, M77, but it's near the star of Menkar. Cetus is a big constellation, though, and that's probably pretty far over in the east yet for Mark.
Yeah, we'll have to look and see.
It's over.
Cetus.
Menkar is just south of Taurus.
Okay.
Like I said, it's a big constellation.
Wow. All right, let's zoom out a little bit. I'll just do it this way. And now let's go here. Okay. Darken up our sky a little bit. Ah, there we go.
That is gorgeous.
It is. Marianne, tell everybody what time the iDetective show is on KGRA DB.
It is on Wednesday nights, 6 p.m. Eastern. Myself, Krista Perno, who is also part of another show called, I believe it's called What's Up, MUFON, which is also on KGRA. But Krista Perno, myself, John Savage, and Randy Sutton, we're all retired police officers from New York, Arizona, and Las Vegas, Nevada. And we just have a great time talking about all kinds of stuff that's going on in law enforcement these days. And there is a lot of troubling things going on in law enforcement these days.
Yes, without a doubt.
I would rather be out there right now in space other than in some of these cities around the country.
Yeah, I agree. Well, thank you, Marianne. I, of course, wish you the best of luck on the show. You've been doing it now for how long? Almost a year.
It's been about a year. Yep, about a year. Yeah. And what's kind of cool, if anybody out there is into any kind of police shows or podcasts, we now have, I believe, 4 law enforcement shows on, and they're all Wednesday night on KGRA DB. And I believe the first one starts about 3 p.m. Eastern. So it's kind of cool. We've sounds like they're making it the law enforcement night, which is kind of neat.
That's cool. Very nice.
So.
Wow. Now, you see, you got to say that to Tchaikovsky's Waltz of the Flowers.
Ah.
You didn't know that because you don't hear the music.
Yeah, because I can't hear it. That's cool.
Yes.
But
you had music in the background. I didn't share the sound because then, you'd be hearing the music and it could be loud compared to the voice. So, hey, I just did it this way.
I appreciate that. Thank you. And I've got to say, I'm learning so much from these streams. You and Daryl are absolutely amazing, and I just learned so much. There's so much to absorb.
Yeah.
And it's great. And I appreciate your explaining things in simple terms that we can all understand, and that really helps.
I'm glad you enjoy that. I want to just say hi to, I think it's Lynn Yera, who writes, Hola, ¿alguien que habla español? No, lo siento, aquí nosotros hablamos inglés, por favor. So if you're going to send any messages, do so in English, because we're doing English. I hope you don't mind, but we do appreciate you here. And although I speak some Spanish, the rest of the people do not. In any case, welcome. And make sure you subscribe if you haven't subscribed yet.
I'm sorry.
What's the
when
matter?
I was in Germany, I tried speaking English, and they go, "Pardon me, sir, do you speak English?" Excuse me, I tried to speak German when I was in Germany.
Yes, that's what you meant.
Pardon me, sir, do you speak English?
Yeah. That's right, Starzar. We are gazing upon the sculptor galaxy. Is it just a little philosophical note here? I'm an astronomer. That's what I got my degree in. So I spend my night looking at objects. I spent years researching objects like this. And one of the things that I think is important to understand, and it's something that I feel firmly, and it's why I named my book The Populated Universe, is because I think that the universe is full of life. And I don't think it's always going to be life that is intelligent. Intelligent life is a side road. It's not a foregone conclusion or a guaranteed destination. So And we are exactly like we are because of 5 major extinction events that happened on this planet. Okay? Dinosaurs ruled this planet. But that happened because of a major extinction event that was 252 million years ago in the Permian era. And that's a large volcanic eruption that happened. I'm getting to why this is important here, don't worry. It happened in what's known as Siberia now, a location called the Siberian Traps. And an extremely large quantity of carbon dioxide was basically leached out of the ground, out of organic compounds in the ground, and sent into the air over a very short amount of time, many gigatons. Okay, that's billions of tons of carbon dioxide. It went into the oceans, it heated up the oceans rose in temperature. The temperature on the planet rose 21 degrees in just a few months. And that was enough to kill off almost all the phytoplankton, which make the oxygen, and thus animals that require the oxygen in the water died too, because oxygen doesn't like to stay suspended in hot liquid like that. So we lost 98% of the life on the planet, including the animals that would have become mammals, which we are. So we were already heading toward dominance in the Permian period, and then we got wiped out. Okay, and then 65 million years ago there was an asteroid strike, as most of you know. It was called the Chicxulub impactor, and that killed off the dinosaurs through a chain of events. It sent up a giant pall of global dust, which made the Earth look like a dust ball from space. And that dust kept the sun from reaching plants. The plants that were eaten by the plant eaters died. The plant eaters then died. And the meat eaters that ate the plant eaters died. And it was a chain reaction. And we lost a lot of the dinosaurs that way. In fact, most of the dinosaurs. And so the little creatures hiding in the shadows, they came back out, were once again those things that would become mammals, that would become us. So it seems like the universe has a template, is what I'm getting at, to make life based on carbon like us, with DNA like every single life form on Earth, and with symmetry like we are, based on the way DNA replicates, I would think. And so keeping that in mind, here we are looking at the Sculptor Galaxy, and the question you have to ask yourself is there life out there looking back at us? And I imagine that the answer to that could be yes. I mean, we're a fairly small to moderately sized galaxy, 150 billion stars. The Andromeda Galaxy, on the other side, for instance, has almost 1 trillion stars. That's 1,000 billion. So we're talking 150 billion to 1,000 billion stars. That's a lot of possibilities just in the Andromeda Galaxy. And now this galaxy here is another galaxy that I don't know the size of, how many stars it may have. Daryl, you might be able to look that up for you while I'm doing this. But the bottom line is that we could be looking at life. And if you look at the galaxies, one of the things you'll notice is that the center of these galaxies tends to have a yellow hue. There's older stars in here. And the outside of the galaxy, and I'll show you why they're older, okay? The outside of the galaxy has bluer stars. That's because in galaxies, stars form in these spiral arms. These are spiral arms seen kind of on edge. You turn them like this, and you'll see the spirals, but on edge, you just see the narrow runs like this, little circular areas, but they're actually spirals. And the stars form in there, and that's where the new young hot stars form, and that's why they're mostly blue, because that's what color new hot young stars are. So in this case, there could very well be stars that have formed and migrated away from their hot young cluster and actually started to form planets. And possibly those planets could have life, because it happened here. So why can't it happen there? See, I don't believe that. I think it could have. Go ahead, Daryl.
To answer your question, NDC 253 has about 100 Oh God, I forgot. Let me go look again. Give me just a second.
No worries.
100 billion, 100 billion masses, solar masses. It's about 45,000 light years radius, so it's maybe a little smaller than the Milky Way, which they say is 100,000 light years.
Yeah.
And 100 billion solar masses, if you want to turn that into stars, well, it's comparable to the Milky Way.
Yeah. We might have 150. But you know what? We can't get an accurate star count of our own galaxy because that's like being inside a forest and saying how many different kinds of trees are in here. You can only see the ones you can see. You can't see past lots of trees. In fact, you get to a certain point, you can't see past them anymore. That's why we only have a tiny little window to see into the very center of our galaxy. But the other side, we've never seen the other side of our galaxy. Ever. And we probably never will. But we've been there. We've gone around the galaxy almost 20 times since the Earth was formed. So, you know, we have a lot going for us.
Now, Mark, when James Webb goes up,
Oh, yes.
will they be taking pictures on the other side of the galaxy, or are they going to be focusing not on our galaxy, but maybe out Andromeda and further galaxies?
Well, the thing is that James Webb is only going within our solar system, and we can't see anything beyond where we can see in our galaxy from anywhere in our solar system. We'd have to go several thousand light years in one particular direction or another to see something new, because we just don't have that ability to see, because it's a really big forest out there, Marianne. So it's a large forest of stars, large forest of galaxy structures and everything. And to move all the way to the outside edge of our solar system wouldn't change the view one bit of our galaxy as seen from out there. So I think that's pretty interesting. And Daryl's putting up some information about the Sculptor galaxy. Most galaxies seem to have in their heart what we call an SMBH, a supermassive black hole. And our galaxy is no different. In fact, we did a 10-year study, not me personally, but as astronomers, we did a 10-year study of the center of our galaxy, and we actually saw stars orbiting something invisible, moving fast when they got closer to it. That's a black hole that's in the middle of our galaxy, a supermassive black hole at the middle. And we've seen the same thing in the Virgo galaxy, M87. And it's such a massive galaxy, such a massive black hole, that it's many times bigger than our entire solar system. To get across the black hole from one end to another, if we could travel it, this black hole, this supermassive black hole, the center of Messier 87 in Virgo, it would take us something on the order of probably, about 65 to 75 years minimally, maybe more. So that's pretty weird.
Say that again?
If we were to travel across the diameter of the M87 black hole, it's many times the size of our solar system. I think the last I heard was between 3 and 6 times the size. So it would take us anywhere from 50 years to, say, we could even go up to 200 years to cross the face of the black hole alone.
Okay. I read just the other day they've detected a pair of supermassive black holes orbiting each other. They're very close together, and they're in the center of, I forget which galaxy, another galaxy.
Yes, I read that.
And, I guess they're maybe looking forward to the merger with them.
Yeah.
That would make quite a splash for the gravitational detectors.
Yeah, see, that's the thing, guys. It's been theorized that when we see things like gravitational waves, think of them as ripples in the water, right? When you drop in a pebble, you have these ripples that move away. Well, gravity does the same thing. When there's a disturbance in the gravitational force, it will ripple as well. And those ripples can be detected here on Earth, and they have been. There's a detector, it's the Laser Interferometric Gravitational Wave Observatory, otherwise known as LIGO, L-I-G-O. And LIGO has detected them. The Virgo detector also, that's in Italy, I believe, has also detected gravitational waves. And we have one of these LIGOs, I think, in Louisiana, and I think one in Washington State, if I don't miss my guess. And,
I think you're right.
Okay, and these detectors detect the disturbance created by gravitational waves, and that is to say, a gravitational disturbance. When something changes rapidly, we can detect it. So, when two black holes collide with each other and merge, massive waves are sent out, ripples through space and time, and we can see those, and we catch them here on Earth. Pretty cool. Hey, James Dugan. James Dugan there is from Australia. So he's sort of in the middle of his day. Is that not true, James? What time is it there? He'll tell us. So yeah, this is the Sculptor Galaxy. It looks pretty, doesn't it?
That is beautiful.
Daryl, this is another
in?
winner. Yeah, I can, actually.
Yeah.
Let's zoom in and see what's...
Let's see what's what, huh?
Heck yeah.
Oh, if this was farther north in the sky, it'd be a much better known object to people in the northern hemisphere.
I think so. I think you're right. Yeah, this is just a stunning object. It's really, really cool.
I read that for galaxies in our neighborhood, the local group, I guess, actually only Andromeda and the Sombrero Galaxy beat it for
Really?
big and bright.
Wow. That's pretty cool. Interesting.
It's really pretty.
Yeah.
And that one kind of orangish, yellowish dot near the middle, I wonder if that's the center of the galaxy or an H2 region. Yeah, that right there. I see other red dots in there that might be H2 regions.
Yeah.
Tons of detail in there.
Yeah.
Some people call this the silver dollar galaxy.
Yes, you've said that. And see, what this would look like from the side is a long, thin object with a bulge in the middle. Kind of like a UFO on edge, okay? And that's kind of what these galaxies look like.
Big fried egg.
Yeah, I thought so, James. 12 p.m. on a Friday. That's what I thought it was going to be like around noon for you. Well, thanks for joining us, though. It's nice to see you. Must be weird, huh? I mean, this is why, people who believe the Earth is flat, they don't want to talk to guys like James, because when he looks at Orion, it's upside down compared to what we see. Shh! You can't tell the flat Earth people that, because Orion doesn't look upside down to them. It can't be upside down in a flat world, so shh. Yeah. For James, it's upside down. And James says hi to you, Marianne.
Hi, James. It's so good to be able to talk to people,
Isn't it?
Instead of just writing things down, it's so cool that I get to actually voice saying hi to everyone in chat. I really enjoy that.
Isn't that nice? You're not stuck having to do your work on the iDetective show that you do as a co-host of that show. You actually get to interact with all of our people and just hang out.
Oh, I love it. Everybody's so great, and I feel lucky to be on the show with you guys and be able to talk to everybody in chat.
Well,
I do have a question right smack dab in the middle. It looks like there's a peak kind of just to the right of where Daryl was talking about the orange. Go just a hair to the right.
To the right?
Go right there. You're almost on top of it. Just a little bit more to the right. Right there. That almost looks like a peak.
Oh, it almost does. I see what you're saying. Yeah, you got to remember the universe is in 3D, and we could be looking at a part that's probably a part of the star clouds of this galaxy. And so we could be looking at star clouds that are moving or are higher in the galactic plane than lower, and so it's pretty cool,
That is so neat.
Yeah. Hey, Greggy Gilgan. Oh, you're in Adelaide. Okay, so you're in the same country as James Dugan. James is at a different time zone than you are. But it's 1:45 for you, and it's noon for him. Wow, that's cool. So he's in Sydney, the time zone anyway. Very cool. Very nice. See, we have people from all over the world here. That's what I love about this. Yep. And Daryl's responding to your question, by the way, about the Helix Nebula. It could be a spherical shape, or it could be a kind of a barrel where you're looking down the opening of the barrel. I know that people have talked about that, but I also think, what are the chances in a nebula like that you're looking straight down the barrel at all times? Why not just slightly off center? Why not like this? Okay, but how come it's going to be down the barrel? It doesn't have to be. I think that's a spherical nebula, the Helix, not this. And so what happens is, at the front and back, you can see through my fingers, see? But you go on the edge and you cannot. And that's because there is more material along the edges. And so no matter where you see it in space, it's going to look like a spherical object with a hole in the middle. That hole is from the lighter density of gas, but you're looking through less material, right? But on the edges, you're looking along this long edge of material, and it's going to be denser looking, so it's always going to look like a donut to me. I think the Ring Nebula is one such thing as well. Now, if they're oddball shaped, if they're elliptical in shape, then maybe we're looking at them from an angle, and maybe we can get that barrel shape. So I don't know. I just don't. Jury's out on that. I don't buy the barrel shape thing for these things like the Helix Nebula and the Ring Nebula.
Well, some the Helix, for instance, the fainter clouds off to the side and that kind of corkscrew appearance it has, I think that may make some people think, if not spherical, maybe spheroidal, or make some people think of that barrel shape you've mentioned.
Sure. I don't doubt it. I understand. Okay, something you might have noticed in the time since we looked at this just a few moments ago. We've reached a certain threshold, and now the color has come out even more. All I did was enhance the color a little bit because the color had come out. So we actually see now that there's some really nice color. And you can see the blue here. You can see some hot OB associations where there's young hot stars mixed in amongst these dark lanes right there. There's some up there too, and up there. Then you see some reddish distended areas, and those reddish distended areas are basically Orion nebulous. They're H2 regions of star formation in this galaxy, and my pointer is going to different ones of them right now. Okay, there's one there, one there, one there, one there. Lots of star formation going on in this galaxy. Okay.
Yeah. It's
really
interesting.
Really nice.
I see now, rather like we've noticed in some of your later images of Andromeda M31, out at the far tips of the spirals on both sides, we're seeing blue features showing up more than they used to.
Oh, yeah.
Excuse me. Like OB associations or whatever. There's one there at the bottom right, and maybe a little fainter, but there's some up at the top left too. Yeah. Very blue.
That's right. And we see those in the Andromeda Galaxy as well. Which I think you just said, didn't you?
Yes.
I'm sorry.
No
yep. Yeah, so I think that's something else. And maybe we'll check out the Andromeda Galaxy too. I think this is kind of a cool spot right here.
Yeah, that's the one I was talking about, yes.
Okay.
That's very reminiscent of the one in Andromeda is bigger and brighter, but very reminiscent.
Yeah, I mean the sculpted galaxy, Andromeda is 2 million light years away, Okay, and the Sculptor Galaxy is like 11 million light years away or something like that. So it's quite distant relative to the Andromeda Galaxy. You see? So what's the other galaxy you said was here that you wanted to check out?
We've looked at it before. It's M77, but it's over at the far end of Cetus, and it's quite far away, and it's nowhere near the zenith yet, and you might be fighting the roof to look at it.
Yeah, I might be fighting the roof. Yeah, I actually, if you look up above me here, guys, that side of the observatory right there is toward the east, but we have, with the sensitive camera anyway, you can see the lights of Phoenix 65 miles away. Okay, and there's a dome of light, and so I put the roll-off roof on that side, so it's going to block part of the view, not because there's light, but because I don't even want the remotest temptation to try and look at an object in the east when it's going to look crappy. So we're just going to wait for it to make its way into the good part of the sky, where we're going to have the southeast, south, southwest, west, and all of the north and northwest and northeast. So that's fine. Actually, every observatory these days has issues with light pollution. There's not many that don't. You know. And Marianne, you're still awake?
Barely, but yes.
Well, that's what I was asking, because it is.
Hey! I was up at 4:30.
It's 8:20 for you right now.
I'm still on cop time. Give me about another few months, and I should be getting to normal time. Hey, the other night we were looking at during kind of a private stream. I want to call it the witch's. It's not the witch's broom, but we were looking. It almost had the outline of a witch's face.
Yeah, you were talking about the Eastern Veil, I think.
Okay,
with
you
that
think
beautiful
that's
ribbon
up?
of
I know
color?
it was hard. Yeah, I know.
The witch's face?
Yeah, that one. That
we tried to find the witch's head.
witch's head.
Yeah.
That's next to Rigel and Orion, and it's not up high enough yet to look at.
I don't think she was there with us for that one, Daryl, because that was really late.
I think she was.
Yeah, I was.
Really?
Yeah,
what are you doing up that
11
late?
o'clock at night. I know.
Go to your
kept
room,
me up.
young lady.
You made me
Okay.
stay up late.
Well, you know what? It's all right. Go ahead, Daryl.
Oh, well, it was getting late, but I don't think Orion was up very high yet. We tried to see it next to Rigel. We couldn't pick it out yet.
Yeah, we had a problem with that.
It is rather faint.
Yeah.
It's quite large also.
Mm-hmm.
So what do you think? Later part of December we might be able to, you think? Or
Oh yeah.
January?
Later in the year.
Okay.
Yeah.
Well, late December, Orion should be transiting the meridian about midnight, and that might be a good time to look.
Okay. Hey there, Keen Tribe. How you doing? They are from Alaska.
Oh wow, that's got to be cold.
Well, they have ice and fog right now. But
Wow.
welcome. I'm so glad you're here. It's below zero for you guys, and it's cold here, but not as cold as your place.
Wow.
All right, we're going away from this. I saved the images, so basically I saved it exactly as seen. I saved the stack, so it will show up on our live server, where you can go find this probably within 10 minutes. So enjoy that. And what I'll do now is bring us back, and we'll get rid of the stack for now. That image will stay in the buffer, even though I get rid of it here. And we're going to go down to 1 second here on our camera control system up there.
Mark,
And
excuse me a
now,
moment.
yeah, go ahead.
All right, surprise
now-
me when I come back.
What?
Surprise me
Oh,
when I come back.
okay.
Mark, I love Keen Tribe says that it's a dry cold. It's so funny they says that because here in Arizona we always say it's a dry heat.
Yeah, it's a dry
Oh.
cold. Yeah, okay.
That's cool. I like that.
Yeah, yeah. That's like people who tell me, this wine is such a dry wine. No, it's not. If you throw it on, you're going to get wet. I mean, I don't know why they say dry. I don't get such a thing. That makes no sense. That's just me.
Yes.
Okay. All right, so Daryl says to surprise him. So you know what we're going to do? We're all going to get up and leave. When he comes back, he's just going to hear crickets. There's going to be nobody here. Actually, I wanted to look at the Burbage chain. So we're going to head up north a little bit to the Burbage chain. It's an active galaxy. Let's go find out what it looks like. So we're moving up, heading up. We're moving to a star that's going to be our point of entry to this location. And let's see what we got. So we're getting there. So we're heading up to a star, and the star we're looking at right now is going to be Difta once again. Then we're just going to drop down to the south a little bit to the Burbage chain. I've never seen it before. I never looked for it, so I have no idea. Oh, we got something there.
Ooh.
So that's kind of cool. Yeah. All right, just a second. All right. And
Down below, I don't see the readings on the controller. Did you must have hid them?
No, I didn't. That's actually, they'll come back right now as soon as I do this.
Oh, okay.
They time out. They time out.
Oh, okay.
And I'm going to center up this galaxy. All right. And then we're going to give the 15 seconds or so, 10 seconds, 11 seconds we need. And then we're going to take a long exposure of this galaxy and check it out. It'd be interesting to see.
Oh, heck yeah.
So let's do, we'll do 35 seconds. And then, hey, welcome back, Daryl.
Also,
you know what we're looking at? That's the
last one.
That's the last one. We're going to get rid of that. Okay. Well, we're going to find out. It is a galaxy, and it's one I've never seen before, so we're going to be checking it out.
Me neither, probably. Like I said, it surprised me.
I did. I'm going to surprise all of us. Hey, Starzer, that's pretty cool. Starzer says he's getting a lot of synchronicity because his son's name is Keenan. Well, my youngest son is Hunter Orion, Orion, and my oldest is Gabriel Galileo. Astronomers' kids, you know. Okay. That's pretty cool.
Looking good. Yeah.
Alright, so that's what it looked like right now. I'm going to drop this down a little. Pull down our dark level a little bit. And I don't want to go too far. That's about it. Great. And let's see what we got. This is an active galaxy, Daryl. It's called the Burbage chain.
Oh, yeah, I remember you noting that earlier.
Yeah.
Interesting.
Yeah, and you can actually see it's got a really interesting shape to it. And I'm going to clear the stack because I'm noting a little bit of motion. So we're going to do it again. Hey there, Cypher. There we go. And now it's looking much better.
It's
Cypher,
like a greenish tint. Greenish tint to it.
Yeah, I just gotta do a little color correction.
Oh, okay.
And I'll do the color correction after the second frame comes in.
Looks like another tilted spiral.
It does. Look at that. Okay. Here comes the second frame. You watch the noise here. This modeling. Ready? Doom. See how much that went away? That's what stacking does for us, guys. It gets rid of all the noise. Now I'm going to correct the colors in the image. Okay, the background is a little bit more like it should be. And now I'm going to reduce our red level a little bit. There we go.
Spiral arm at the top looks quite distorted.
Yeah, and look at this. There's like a hole. Susan, that's a very nice thing to say. This is one of your favorite places. Hope you... Oh, that's very nice of you. Wow, stars are is born on February 19th, just like Copernicus. That's cool. That's cool. And, you know, there's more in this galaxy going on. Let's do this. Let's also make this full size. Ready? Boom. Go. Full size. Come on. Do the full size. Oh, I guess I should do this too. Okay, so let's get rid of this. Alright, now it'll go full size. Finally. Go. There we go. That's really pretty. Let's zoom in a little.
That's interesting. Yeah, you can see almost like a hole in that upper spiral arm.
That's right.
And it looks quite distorted, like it's interacted with another galaxy.
Yeah. That's pretty interesting. That's really interesting. I'm liking it. I'll take the name off for just a few minutes here. Wow. Let's zoom in some more.
See the bright core of the galaxy, and
yeah.
See a little faint detail coming out of the lower arm also. Maybe it's distorted too.
Yeah. As we
off to the left.
Yeah. You know, as we actually zoom in, we're gonna end up seeing detail, more and more detail. But I think you'll notice as we zoom in, you can see other things too. You can start to see some additional clumping over here. These look like maybe hot O and B stars. We call them OB associations here. Again, as in the other galaxy, the center has more yellow stars. The outside has more blue stars. And it looks like we have some kind of an active area right here. Maybe that's a hot starburst formation area. There's some here and here. And this arm is definitely distorted.
Was this called Burbage's chain or something?
Yes, it is.
If you look at about 10 or 11 o'clock to the main galaxy,
right
there's
there,
a whole chain. There's a chain of galaxies right there.
Yeah, that's what this is for. And there's another one here.
Yeah.
Yeah. Now this is yeah. Remember, I have the name which I got rid of just now, but this is the name right here. You can't see it because you're not on that screen, but I had Burbage chain on the screen.
Okay.
Yeah. Okay, it is this Burbage chain, and you can see this chain of galaxies there.
Very cool.
Something new. We've never seen this before.
Sort of like seeing Markarian's chain in the Virgo cluster.
That's great. Markarian's chain is another one that's we're gonna have a lot of fun looking at, guys. Let's see if we can just tease a little more by monkeying with this just a little more.
Scope's really performing tonight. Wow.
Oh yeah. Look at that. Isn't that cool? And let's bring the dark level down globally. Okay, we'll still be... There we go. That's kind of where I want to be, right there. Pretty good, huh?
That's great.
It is absolutely amazing. Wow.
Yeah.
A lot of detail in it.
Yeah. So, in discussing this galaxy, let's just take a look at it real quick while we're actually, we've got 10 frames stacked right there. The galaxy itself, this one here, the Burbage chain, this particular one, NGC 247, is 11 million light years away. Okay, and that's pretty good.
That was the same distance as the Sculptor Galaxy, right?
Was Sculptor that far? Well, let's find out. Let's go back to the Sculptor Galaxy and just get a distance on the Sculptor Galaxy.
Thought it was 11 million.
Yeah, it's 11.6. This one is 11 as well. It's 11.4. So these are literally in the same part of the sky and could have interacted with each other.
Yeah, and they're both active galaxies. I wonder if that's why.
Maybe so.
They could very well have interacted with each other.
Yeah. And so just to point this out once again, right here where my pointer is, there's a galaxy. Okay. Here's another galaxy. Here's another galaxy. And then we have this galaxy here. This might be, I have to check, I don't know about this object, but this might be another galaxy seen through this galaxy. We have another galaxy right here. So we've got many galaxies in this one view.
Yeah, up at the upper edge of the one to the upper left, I think there's a couple, 3 more going back
here?
up toward the top of the screen. Yeah.
Yeah. That could also be true. Actually, we can support zooming in quite a bit more right now, so let's just do it. Let's go to 100% and then make our way up to the top. Let's go see. Let's go see, Captain.
And you guys know these are galaxies because they're faded. They're not as brilliant as the other stars that are surrounding this.
That's definitely part of it. That's part of it.
Fuzzy.
Yeah.
They're fuzzy.
Fuzzy, yeah, okay.
That's part of it, yep. I think we might even have one right here. Not sure. But this is definitely one right there. You can't miss it. That might be one too. I was calling that one for sure. That one's for sure. And then we have
247.
245, I think. Let's go back. Let me see. Maybe you're right. Let's look back. 247. Yeah, sorry. Not bad. That looks pretty good, as a matter of fact. Wow.
Oh, yeah.
Not bad, guys. Not bad at all.
Okay, no.
It's not bad there, hey, but want some beans, boys? Yeah. All right. So, that's the Burbage chain.
Oh,
And
there's the
we've
Claw
stacked-
Galaxy.
Oh, well, I guess that makes sense, doesn't it?
Gravitationally
cool.
bound to NGC 253.
Yep. That's the Sculptor Galaxy.
Center of the Sculptor group.
Yep. Wow. You can see these large areas inside this galaxy. Let me bring it up out of the way. Let me just get rid of the name for now. Okay. Let me back down. You can see, when you look, you can see these large blotchiness in here. Those are actually areas within the galaxy that are probably locations where there's very, very bright hot stars that are formed in clusters, associations of hot stars. So it's pretty cool, you know. And James is saying it'd be pretty cool if that's if this was a supernova here. That is a foreground star, James. I'm sorry. So are these two here. and that one, and probably this one, and maybe that one. But we're seeing through a veil of very thin stars, we're seeing a much more distant object. Really pretty.
Yeah, several that of the smaller galaxies you noted, they are shown in a image from Lucilla, I believe. All those plus that one down just to the left of the main galaxy.
Here?
That
right
one?
There?
Yep, shows all those.
Let's show this one too.
That one I think is outside the field. Let me look again.
Okay.
Yeah, it's outside the field.
All right.
You can see several of the ones on the left side though.
Really, this is really something. So we've stacked 20 of these images. That's not bad. And we're at 78%. Let's go to 100% and see what it does.
And there are a lot of H2 regions in this galaxy also.
Yeah, you can see a bunch of these reddish areas in here. Wow.
It's really something, Mark.
Yeah, not bad. First light.
It's cool.
Seeing this.
Me too.
Okay, and now let's go back to our full frame here. And let's go into our stack. We have 21 objects, 21 stacked. We'll pause this. We'll save the stack right there. The green bar across the top shows you that. Okay. And now we will save exactly as seen. So if you just want pretty pictures, you can go get them. Okay. And now we'll get rid of this image here, go back and do 1 second. And with a 1 second exposure, we'll go into our Finder mode where we have the hyper mode here. And now let's go find something else. What you got, Daryl? Any ideas?
Look at, you guys looking to the left. Is that satellite? It's just something small coming almost out of the view. Yep.
Where is it?
You missed it. That was pretty cool.
Call it a cluster. They are physically associated. I guess you could call it a cluster, or a group. It's called the Sculptor Group because they're all up in the constellation Sculptor, but they are physically associated with each other.
Okay.
And
that's
the one we were looking at, the NGC 247, it is gravitationally bound to NGC 253. They probably have gravitationally interacted in the past, which is the distortion and all the star formation in the H2 regions we see.
Possibly, yeah.
Both are active galaxies. I would imagine the interaction, stirred them up and woke them up.
Oh, for sure.
What do I have next? I don't know.
Let's see now. We're in, I want to be in Cetus, the whale.
Yeah.
And we look at the whale. This is Cetus here. And at the other end of Cetus, you said there is something else to look at.
M77. Another galaxy.
Alright, well, that's good. Let's see if we can... Let's see what
the
that's
bright
located.
star there in the head, star's name is Menkar. That's Alpha Centauri.
Right. And that's kind of where this is.
Yeah, and Alpha Centauri was, of course, the star where Captain Kirk stranded Khan in the Star Trek episode Starseed, I think
That's
it was.
Right.
And then where they went back and found him again in Star Trek II, The Wrath of Khan.
That's right. Khan!
This is CD Alpha 5.
That's right. Oh, that's funny. That was a good episode. Okay, so let's see. We're pretty high up there. Let me just check out our directions from here.
So, is that supposed to be... That's a whale?
Yes.
Yes,
Wow.
that's a whale. That's what whales look like. They have these little things around them. Okay,
It almost looks like a...
these veins. Okay, look like vampires. Okay, that's what whales look like. No, I'm kidding.
Okay. It looks more like a dragon.
It does, doesn't it?
Marianne, in the past, Cetus was called the sea monster.
Okay.
And if you've
So
heard
that
me
makes a little
talk
more
about
sense.
The whole Perseus, Andromeda, Cassiopeia, and Cepheus story,
Yes.
this is the monster that they were going to feed Andromeda to, and Perseus showed
Jerks.
the Gorgon's head to the sea monster to turn it to stone, so he could save his girlfriend.
Oh, wow.
Right.
That is cool.
So there's Menkar. So Menkar is now perfectly visible. So I have a feeling we're going to be able to see this without any obstruction. You'll notice the building over my head. And we're going a little bit south and not far. Oh, look at that. Okay.
There's actually a couple more galaxies up to the upper right of it.
Yeah, look at that.
Yeah.
That's a beautiful
Now-
That
field.
is neat.
I don't know how well we'll be able to see M77. Messier saw it, of course, but it
it's
is
bright.
it is smaller and brighter.
Yeah, it's an
Try
SA.
to
Which,
image it.
yeah, an SA galaxy, capital S, and then a capital A is a special type of spiral galaxy, and then a B indicating that it has arms that are not as tight as the A, but not as loose as a C. So they measured them A, B, C, little a, little b, little c. This is a capital S, capital A, which means active galaxy, I believe.
We have looked at M77 in the past through your SkyTour East Observatory's telescope,
Yeah.
working at F10, so it looked bigger than it will here.
Actually, F6.3. That was F6.3.
Oh, that's right, F6.3. So maybe
So
you'll be
in other
able to
words, it
zoom
is-
in on it and still get some good detail.
Yeah, so let's try it. So let's do a 35 seconds on this guy as well, and we'll get out of our mode here in a moment. But you can see there's a galaxy there, and we got the green progress bar coming across the bottom. And we'll get out of this and go into our stack. Not bad.
Ooh. Oh, that's
That's
the
the old. That's the old,
old one.
Yep. Yep. Okay, so this is Measure 77. There's the galaxy right there. I think we actually could see the really tight spiral arms on this when we zoomed in, if I recall. You remember that, Daryl?
Sorry, I was muted.
I thought you were.
Yes, it had nice spiral arms on it.
Because it's sort of like we're
Galaxy
face
above
on.
this- Galaxy
Looks
above
nice.
is showing.
Yeah. So let's zoom in. Let's go to 75% and bring these two guys into the forefront. Oh yeah, look at that. Look at those spiral arms. Very nice. And let's just move up a little bit. Oh, look at that.
Ooh.
That's pretty. We're seeing once, and again, we're stacking now. So as we stack, what's going to happen is that noise you see is going to average out. Okay, so like for instance, we're almost done. with another stack. So when we get in there, okay, watch now. Okay, it was hard to tell, but the noise level reduced significantly.
Yeah, that galaxy has quite a dark lane across it.
It does. Yeah.
Oh.
Kind of reminds me of the Sombrero Galaxy in a sense.
Yeah, it does. Very much.
The Sombrero Galaxy kind of looks like this, guys. It's a galaxy that has a very dark lane. And we'll just zoom in on this for a moment, and then we'll go back to our other view. Okay. All right, but look at that. This is the dark lane across this galaxy, and you can see a little bit of the galactic bulge here, a little bit of the bulge here. You know? Very nice.
This is serendipity. I've seen M77 before. I don't recall seeing this.
No, I don't think we actually caught it the last time.
Yeah. Can you pull up Stellarium again and see if we can identify the other galaxy?
Sure. Let me just do one thing. Let me
Sure.
let me try to just do a little color correct, and then I'm going to process the stretch right here. Yeah, we should do a little bit of that. Let's see what that does. Yeah. I'm noticing we got a little tiny out of focus, but I'll live with that for now. Live with that for now. That's what I wanted right there. Now you can see this right here. You notice this is one dot right there, and it doesn't look like a star. It looks like some kind of a fuzzy patch in this galaxy. Maybe an active association. Here's a spiral arm that has some detail in it. This is really cool. I've never seen that much detail in here, Daryl.
The other galaxy is called NGC 1055.
Yeah, let's just go up there and check it out.
That one kind of is more exciting, I think. I mean, it's mysterious. I like that.
Yeah, it's a lot of mystery here. And there's 1055, as Daryl just said. And it's also a galaxy that's a SB galaxy, so it's a spiral, and its arms are not as tight as an A and not as loose as a C, so it's called a B. So you got tight arms, looser arms, like our galaxy, and then loosest arms. Actually, our galaxy is more like a C. It's not really like a B. We're kind of like the Triangulum galaxy, but with a few more stars, I think. Yeah. Okay. So let's...
Super.
Yeah, it's really pretty. Let's center this guy. All right. Look at that. That's really pretty. I'm going to go right to 100% here. 100% of frame size. And I'm going to center up this galaxy. Wow, look at that. That's pretty darn detailed.
There are
cool.
damn spiral arms way out around the edges of that.
I see this, yeah.
Yeah.
So I'm not sure. I could increase this to like a much longer exposure, but I'm just thinking this is kind of cool. By the way, those that are noticing, obviously the lines like this, that's an artifact of the tracking system, and it's a pixel that gets dragged across the frame. Every camera has pixels that are what are called dead pixels. And this camera is no different. So what I do is I get rid of those on the final passes of the post-processing. Skunk Ape. Are we looking for the moon of Endor? Yes, we are. Just say it, right? Okay. Why, yes, we are. Move right on. Very cool. That's neat. Yeah, but that's not as far as we can go. Let's go crazy here. Let's live a little. Let's go to 300%. See what that looks like. Wow,
Whoa.
look at that.
Well, you can see a bunch of spiral arms on that. Wow.
See that, Daryl?
Just a moment. Oh, yeah.
That's at 300%.
Yeah.
Yeah, since going out in the desert and collimating the scope and getting things lined up, we've changed the nature of astronomy that we can do here. We now get some very, very good images.
Now, Mark, if you look at it, what would that be, about 5 o'clock, 4 o'clock, 5 o'clock-ish? Remember that dot we saw? That looks like just kind of this part of the spiral arm right there.
Yeah, you're right. See, it's part of this arm now.
Wow.
You're absolutely right. It's part of this arm. So that looked like a dot, but when you zoom in, then it becomes that. Let's go absolutely nuts and go to 800%. Let's see what that does. It'll fill the frame now. Okay, obviously too much. Okay, but you can still see some of the structure.
Wow.
That's cool. That's really cool.
Yeah,
Full frame
M77 is it's a binary system together with 1055.
Yeah.
They are
What that means
associated.
what that means is that 1055, which is this guy up here, and this other one that we just saw, are basically orbiting each other. So these guys are orbiting each other.
And there are
which is
several other small galaxies associated in the area too.
okay. And I don't know.
It's too cool.
Yeah, that's pretty cool. Well, let's actually look at Stellarium and see if we can identify some of these others. So we got Messier 77 here. We got 1055 here. And if you look, we have quite a few. Actually, let me just get our field of view here. Okay, that's our field of view. So we have this guy, and we have what's right here. NGC 1090, NGC 1087, and then this is Messier 77, and directly above it, just about, is 1055.
If you zoom in on 1055, there is at least one very close to 1055. I don't know if it'll show it or not.
Another galaxy?
Yes.
Is it a companion galaxy?
Yes. That's probably pushing it there.
Yeah.
Yeah, it shows up in observatory images of 1055. We may not see it here.
Well, this is Stellarium anyway.
Yes.
And if we come back...
I think 1055 is more interesting than
I think so too.
77 is.
Can you zoom into 1055?
I'm doing it right now.
And both galaxies, again, they have lots of star forming regions in them where I have to assume they've gravitationally interacted in the past.
Could be true. And in looking at this, one of the things that you notice is that you see these red blotches in here. That's called color noise, and I get rid of that with just one shot in Photoshop, and we can actually get more detail out of this. But this system does a pretty good job of doing all the processing. We're going to have to go to a different focus level here, though, pretty soon. The temperature in the building is going down, and the focuser is dependent, as all focusers are, on temperature. And the focusing system we use is this one right here. And now the temperature's gone down 2 degrees from the 69 it was before. And so we have we have tens of thousands of focus locations that we can use. So I'm going to see what we can do about fixing that.
M77 was actually discovered by Pierre Machine, who communicated it to Charles Messier, who then added the object to his catalog.
Very cool.
M77 is the safer galaxy.
Mm-hmm. Yeah, that's Seyfert, Seyfert, Seyfert.
You said it's a Seyfert galaxy?
Yeah, it's the kind of galaxy.
What does Seyfert mean?
These are energetic galaxies that they have a specific set of characteristics that distinguish them from normal galaxies. I could tell you more in a second here. I'm just looking at something here. Now I can look up your definition to show you what that is, because I actually never did any work on a Seyfert. Let's say Seyfert or Seyfert galaxies. Let's look those up and give you the definition.
Vera Messier did use a 100 millimeter 4-inch refracting telescope. Per her earlier question, I just had to look it up.
Okay, I wasn't sure what Seyfert galaxies actually have really powerful nuclei that are actually show ionization lines, emission lines that set them apart. They actually very light, high surface brightness like this one. So these Seyfert galaxies are actually only account for like 10% of all galaxies. So, but they're still very bright, and they have an awful lot of properties that set them apart, like the emission lines in the nuclei. They have like their nuclei are like things called quasars. But that doesn't help you much because you don't know really what a quasar is. So it stands for
okay. I know there's people out there
object.
that probably understand that, but that's what's so cool about your show and the stream is you explain things. Daryl is giving us the history, and it's so cool. Not only are we seeing whether they're nebulas or galaxies, whatever, you guys are explaining things and giving us history and the backstory of these, and it's so cool. We appreciate that tremendously.
Well, I mean, that's what it's all about, right?
Wow.
M77 has a tremendously bright nuclei.
Daryl, you were very low on that. What's that?
I'm sorry. As you said, being a Seyfert, I guess, M77 has a tremendously bright core to it.
It does.
What we're seeing in your image.
Yeah. Okay, we're going to pause here. Save this. Save exactly a scene. And then move on. Okay, so we'll get rid of this here. Come back up. Go down to the 1 second from 35. And now there we go. And now we can go take a look at something else.
You wanted to look at Dark Nebula tonight. We've been looking at galaxies all night so far.
I know. What can I tell you?
I think that's too cool right there. I like 1055 better than I like M77.
Yeah, M77.
I agree.
Oh, what do you know? No. No, it's pretty cool. No, it is very cool. There's no doubt about it.
Thank you, Mark.
No doubt about it. What's that?
I said thank you.
Yeah, it's very cool. Okay, so do we have any more? Go ahead.
Oh, I was just going to say, see ya, con. Saying goodbye to Ben Carter.
Okay.
That was
Well,
cool.
let's while we're at it, let's check out NGC 1052. It's a little bit lower. It's probably going to go to this star to align us. And this star is what? Aza, if that's where it's going to go. It may or may not. I'm not sure. It's Eridanus.
It's a river.
Mm-hmm.
That's a great big constellation. It wanders way across the sky.
Oh, yes, it does. Okay, we got the star, and now we're moving to the galaxy. Oh, wow, it was all the way up there. So it's zipping down. It's moving on down. There it is. That's, I think, right there. And another one right there. And another faint one right there. Look at that, we got 3 in one shot. 1, 2, 3 at the very least. That's pretty cool. Let's go see exactly what we're looking at.
The one on top looks really cool.
Yeah, it
that
does.
would be
It's
interesting.
a tiny little needle. Oh yeah. Well, that's an active galaxy there. And that's going to be this guy, I'm going to guess. Right? NGC 1022. And we wanted to look at this guy, which is the SB. And right next to it, there's another one that says. But we're also looking at NGC 1084. Oh wait, maybe we're looking at this one too. I can't tell, there's so many. Oh, just wait till we look at Virgo. Holy cow, we'll be lost. There's a faint galaxy here. There's a pretty bright galaxy here. And then there's another edge-on galaxy here. Should we just take a long exposure and see what we got?
Sure.
Heck yes.
I see several very dim ones above center.
Yeah. Yeah. Well, let's find out. Let's do a 45-second shot here. Okay.
Thank you, Isabella.
Oh, thank you, Isabella.
She's right on top of
Isabella's amazing because you know what? She takes our chats and she takes our streams and she goes through minute to minute and she documents what we did when, and she puts that in as a comment on the stream. Isn't that incredible?
It is awesome.
I'm just extremely grateful to you for doing that, Isabella. That's amazing. Hello, Louis Ta. How are you? Yep. She is taking matters in her own hands, and I actually invited her to be on the stream as a co-host, and she didn't want to because she didn't feel that she would serve us well, and I can't buy that for a minute. I think that she'd be great.
Me too.
Oh yeah, she needs to definitely come on. Isabella, you need to be doing this.
I know. She's trying to tell you, Isabella. Trying to tell you. I mean, if she's worried about English, then that's one thing. How about if I clear this? Okay. She's taking notes. There we go. Yeah, she's really got it down to a science. Okay, let's see. Oh, look at that. We got 1, 2, 3 right there. Let's kind of drop some. Let's bring our black level down a bit so we can see. Okay, now let's do this.
That's the upper right.
What's that?
That is quite a red star at the upper right.
Oh, yeah. Yeah. Well, look at this. Is actually a beautiful spiral. Look at that.
Yeah.
And we've got 1, 2, 3, 4 galaxies now. There's another addition. You can see how it sharpens things up. I'm wondering if that's
Now,
a galaxy or that's a star.
Mark, come down.
Yes?
Go
There's
down. Yeah, right there.
Yeah,
Go.
there's another right there.
Right there.
Yeah, right there. There you go.
Yeah. So we have 1, 2, 3, 4, 5, and maybe 6.
There are 2 more to the lower left of the one close to center.
Right here.
Yeah.
Look at that. Yeah. So we have 1, 2, 3, 4, 5, 6, 7 separate island universes at the very least.
Can you zoom in
Maybe
just a
another
little
one.
bit?
Yeah, look at this. There's another one right there.
Wow.
It looks like another one.
I think there's another one just below your pointer too.
Yeah, I moved my pointer, sorry. Are you on YouTube or you're on the Skype or not?
I'm on Skype.
Okay.
The red star close to the edge right now, there's one just to the right of it.
Here?
No. The next red star down?
I mean, right here?
Nope. Over toward the
Well,
left-hand edge.
there's one there.
The left-hand edge.
There's one there.
Right there.
And there's one here. That's the one I was telling you about before.
Okay.
So
Then
we got
that
1,
one
2, 3,
okay.
4, 5, 6, 7, 8, 9. Do I hear 10?
10.
I
6
think
Yeah.
o'clock.
10. Yeah,
6
6
o'clock.
o'clock. Go all the way down. To
Oh, yeah,
the bottom,
10.
Right there. Yep.
So that's 10 galaxies right there.
Wow.
Wow.
That's crazy.
Wait till we image the Virgo cluster. You won't be counting. It'll just be too many.
I always
Not
get
kidding,
lost.
actually. Yeah. Easily. Yeah.
Cool.
Yeah, this is really cool. This is really a beautiful face-on pinwheel. Look at that. You know?
You
Gorgeous
zoom in
face-on
on that
pinwheel.
a little more?
Yeah, I can actually. I was thinking of that. I'll just jump right to like 75% from 34. Then bring it up in the field a little.
Oh,
Yeah.
wow. Holy cow.
It is a nice spiral.
Yeah. This noise is gonna, it'll disappear little by little. Yeah. Really pretty.
Got 2 to the lower left of the one near center.
Yeah, that was those 2 you mentioned earlier.
That
I wonder if those are companion galaxies to this one.
Could be.
Really cool. Very neat. Okay. Yeah, that's a bunch of galaxies, boy, I tell you.
And which one is the one near center in this image?
Well, let's go back to, it's this one.
Yeah.
Yeah. Yeah, Isabella, nice company of galaxies. You're exactly right. Very cool. Yeah, we do see a lot of different types. You're absolutely right, Isabella. She says we seem to see a lot of different types of galaxies here, and we do. This one could be an elliptical. I'm not sure, but I'll have to go look. So, the SB that we're looking at. Is that this guy? No, that's the SA. And that's probably what we're looking at there. Oh yeah, NGC 1042 I think is the SB. No, yeah, SAB. Well, amazing. So is it 1052? Yeah, 1052 is the spiral I think we're looking at. Let's go look and see. Well, maybe not. Yeah, no, it's not. This is the spiral 1042 we're looking at right there. See that?
Yeah.
That's the guy we're looking at. Okay, so now if we come back here, you'll see this guy and then 1042 here. 1042. Not bad. Yeah, we're picking them all out. Yeah.
1052.
Yeah.
52 is the one to the upper left of 42. The
Yeah.
one to the upper right of 52 is 1047.
47, yeah.
And the one to the right of 1047 is 1035.
Wow.
Right. So we have 1, 2, 3, and then 4. Pretty good, huh?
And they're all different types of galaxies. Like you said, one's a spiral. The one up, what was that? 10.
This one?
Yeah, that's that 1035, I don't think. But what type of galaxy is that one?
Well, that's going to be 1047.
1047, okay.
Right? Is that no? Is that not what it is? That's not 1047. It's got to be 1035. I believe that's the one.
And that's not a spiral galaxy. What kind of galaxy is that one?
No, it's a spiral. It's just it's an edge on.
Okay, gotcha.
Yeah, it's edge on to us. Yeah. Okay. Well, that's pretty cool. Okay. Well, we're gonna stop this here at 11.
1052 is an elliptical.
1052 is an elliptical?
Yeah.
You mean this one here? Oh no, 1052. You mean this is 1052.
That one.
Yeah, right. That's
The
what I
bright
thought.
one.
Okay.
That
Yeah.
bright one.
Yeah, I thought I was like losing my mind. Okay, so we're gonna do this. We'll save it exactly as seen.
Keep track of them all.
Yeah, we're gonna. All right.
Been a serendipitous sort of evening tonight.
I know, it's been beautiful. I like that we just do that. Sometimes it's fun to just go cruising the galactic tapestry and see what's out there. Okay, so
Wait till
one thing with
springtime.
oh boy, it's gonna be more like the collision. It's like we're not gonna be able to go anywhere without seeing galaxies. They're everywhere. Okay.
Get up there between Virgo and Leo and Coma there in the realm of galaxies.
Coma
and we'll be
Berenices. Ay, ay, ay.
lost.
We're gonna be going crazy. We will be going crazy.
Too cool.
Yeah, we do have a lot of galaxies here. A lot of active galaxies here too. A lot of galaxies that are undergoing real interesting changes. Okay, let's try this. Okay, let's back out. And then we're just in a small spot of sky. Isn't that crazy?
Too cool.
Yeah. Let's back out some more. And let's look up into the north.
There's Uranus.
Yeah, I see it. Should we try and take a look?
Sure, why not? People can say they saw Uranus.
Yeah. I think this is what we're talking about right here. Not that. I clicked that.
I'm gonna go there. Well, I mean, sure, let's go there, but I ain't going there.
Mm-hmm. Okay, here we go.
Uranus and Neptune, I have
Not very
seen
impressive.
them. They're really not very impressive. You can say you saw them. I saw Pluto once, and well, it looked like one of thousands of tiny little, very dim stars in the field. And
Yeah, except depending on where it is in its rotation with Chiron, to which it's tidally locked, it can actually have a color. And I've seen it, and it looked ruddy brown, kind of a red, almost a rusty color. Very, very, very just a light touch of rust color, which is kind of interesting. Okay, that is not Uranus. We've centered on the star, and now we'll get Uranus in here. Okay. So I'm not sure which one of these is Uranus. It's this one or this one. It's probably that one.
Should be a blue or a green color.
Yeah, I know that you expect that. It's Uranus is a lighter color. Neptune is a little more obvious. So
Uranus is bright enough, supposedly, that you could see it naked eye when it's near perihelion and in a dark sky.
You're right, but we can also see some of its moons.
Yeah.
So, I think this is it. This has a slight reddish cast. This sort of has a sort of a semi-bluish cast.
Yeah. Uranus, you should actually be able to see a disk. I mean, it'll be small, but it will have a disk.
Well, we should actually check that out.
May just be a case of needing more focal length.
Maybe. Okay. Let's actually try to see it with the native scope view. Okay, this is a 170. I see there's a blue color there.
Okay.
Let's actually reduce the exposure. Cut it. Actually, let's take down the gain. If we bring the gain down, we're going to see it with less noise. And the screen will get darker.
I wouldn't be surprised if we're seeing a couple of moons right now.
Yeah, I agree with that. I think that we are. Once I bring it up to, say, about 100 gain, I think that we're looking right there. Is that Umbriel or... actually, I can figure that out. Because we can actually see that in here. So let's zoom in and we'll be able to see with Uranus, we should be able to see the moons. And so that's probably Titania that we're seeing out there.
Yeah. The moons around Uranus, if I remember right, they were all taken from names in the Shakespeare play Midsummer Night's Dream.
Yeah, that's right. Okay. So I can see our focus needs to be worked on slightly. So let's do that while we're here. Let's see about dropping it down, maybe. That looks like it might be a little better. Might be a little better.
See, one at 3 o'clock. There may be one very close at about 6 o'clock.
There is
And
one
then
there.
One farther out at 6 o'clock.
Yeah, it's one here.
And maybe one there at about 8 o'clock. And I thought I saw one close up at about 12 o'clock.
Yeah, I did too. It's right there. Maybe the focus needs to change. Let's go to this other. Let's go to this other focus setting here. See if that helps us out. No. So let's see about going here. Actually, the one further down. Let's try that. And let it settle out. Yeah, no, you can see that's certainly not right.
Yeah.
All right, let's go up to this again. 668.
Better one or two back. I thought I could actually see a little color in the one at 3 o'clock.
Yeah, actually, there was for a moment.
Had kind of a blue tint to it.
Yeah.
Mm-hmm. Marianne, you still awake?
Barely. I'm just really concentrating on this because I'm trying to.
Yeah. Well, we're actually
Check
just
out the
trying to
moons.
check out. Yeah. Hi, Isabella. That's a funny story. We're looking at some sky disturbance here too, so it's making it kind of hard. Makes it kind of hard to adjust focus here.
You're zoomed way in on that.
I am. I'm at 350%. No. This might be okay. Let's pop out a little bit. Let's go to 100% now. When you get zoomed in this much, 100% looks great. Okay.
You could see the moons a lot clearer.
Yeah. That's very cool. Okay, let's try a live stack on this. Alright, and I'll clear the previous one. Right.
You might
Alright,
benefit
let's go.
from
Whoa.
shorter stacks with that too.
Yeah, yeah.
I mean, I see
Alright.
two, obviously, right there, maybe three.
And the third one at the top,
one at 3
yeah.
o'clock, one at 6 o'clock,
One
one
at
at 8
12
o'clock.
Well, and 8 o'clock, yeah. This one just over the top, too.
Maybe one
I wonder
at
if
about
these
5
are-
o'clock.
These could be moons, too. Interesting. Alright. let's yeah, I've got the gain fairly low, so I'm gonna set the gain to 325 again, and then clear it, and we'll do the next exposure. It's gonna be a little brighter. Notice how the noise goes away with each successive exposure. Hey there, Papa Tom. How you doing? Lewis, yes, nice question, but no, the rings aren't visible to us with these telescopes. They can only be seen by real high-end telescopes in space. We could actually do photometry at some point and detect the drop of light as one of its other moons passes behind it, but that's something else.
Yeah, remember, right? The rings around Uranus are
Black as coal.
yes. I was going to say charcoal, but we're almost going there again. So let's not do that.
All right. So let's
Notice
go out.
I say Uranus.
I always do too, because I don't make jokes about other things.
Yeah.
All right.
I try not to, but I do get carried away sometimes. I mean,
Well, you know,
I saw Mae
so-
West and Heart Nebula, and
Yes, you did.
I saw a Bikini Top in the Soul Nebula.
That's sort of an ongoing theme there. It's a theme with you, Daryl. That's all right.
No,
Okay.
I try. I can't always help it.
That's fine. Okay, we're gonna minimize this, and let's go check out. Let's get rid of this actually, and then go back to our 1 second and hyper process this 1 second view. Okay, so the Uranus right there. All right, so the Uranus was sort of a little serendipitous stop. And what we're going to do now is go to see something else. And what is that thing we're going to watch and look for? Well, I think by now, yeah. I think maybe what we should do, I mean, you can't help it, right? If we're up this high, we should probably look at measure 33, but I also really want to see, without doubt, I want to check out our favorite galaxy, the Andromeda Galaxy,
Oh yeah.
because you want to see, because we've been doing all these galaxies, I think it's important to check out the Andromeda Galaxy. Because we just like all the details we see in there. The Andromeda Galaxy is much closer than any of these other galaxies we've been looking at. So here we go. It's also high in the sky, so it's going to be gorgeous. And away we go. And let's see where we're going. Okay, we're going to use this star right here. And it will tell you right here what star it is we're zooming in on. Okay, and actually say using it as a stop-off point. And it's Mirach, which it uses every time for this particular location. And then Mirach also has a little companion galaxy. Has nothing to do with the star. The star is in the foreground. The galaxy's unbelievably much further away. I think that's a galaxy.
It looks like one. Pardon me a moment, please.
Sure. Okay, and now we come in here to measure 31, and this is a much more involved galaxy. you're going to see a lot of stuff here. And I'm going to actually try to focus again, make sure we've got it right. If I wanted to get this right, I would actually bring this up a lot higher and then just do from like here down, because there's so much more outside the field that we can't really see. But we're going to just do this now. We'll go to one more stop here.
That's always so beautiful. It's such a beautiful picture.
Yeah. Well, I want everybody to know that this observatory would not exist without your help, Marianne, Rob.
Well, thank you.
Yeah.
I hate to say it, but I kind of had my doubts. I'm like, there's no way. How are you going to run this 2,500 miles away? And holy cow, this is just unbelievable. I'm so glad that we did it.
Well, yes, I'm glad that you had faith that I could.
Yes.
Look, it took time to sell you on the concept.
Oh. Yeah, but it just, now I've got to say, I think our next project will be a mobile observatory. I think that would be the most amazing project to go and work on.
Yeah, we could do a mobile observatory and take it around the country. I think that'd be kind of cool. I'm working on a lot of ideas for that.
Who was it? Somebody in chat the other night. I can't remember who it was, but they were talking about putting this stream on a large screen outside and have the neighbors come. And I thought that was the most amazing thing to do. I could do that. Just get a large screen and
then have a stream party.
Yeah, I think that would be great. And that's how we could introduce people that have never seen the stars and have never seen the universe in a whole different light, like just what we did tonight.
Well, you know what we could do? Okay, think about this. I'm just checking the focus. I think we're almost there. I got a couple of adjustments to make here. The most important thing, I think, is I'm going to go to this for now just to see it. Let me just get the focus straight and then we'll come back to this. Okay, I think that's probably going to be out of the question. Yes, it is. Good. And now let's go here and go there. And the focus is changing again. It's getting closer, but not quite. Gotta do more. I'm just getting a idea of where I want to go here with the focus.
Okay.
I just stepped out for a quick look, and Sirius and Procyon are up. You can see the whole winter circle from here now.
Awesome.
9:30 at night.
Wow.
Orion is well up now by 8:30 here.
Yep. Okay, I think this is good. Okay, I think this is good for our focus right now. So, I'm going to pop out to our auto frame. I was going to say, one of the things I thought of, Marianne, was we could just, as part of SkyTour LiveStream, we could actually go to different college campuses and schools, and all we're going to have is a big screen. We're not going to have an observatory. We don't need it. All right? And we'll do the observatory run live from all over the country, anywhere we are. All we need is an internet connection.
Perfect. Yep.
Right?
Oh, I think that would be outstanding. And that's it. More people can... It's like you go to these observatories. We have one here in Arizona, in Gilbert, and it's a public observatory. Well, you look through the eyepiece for maybe 2-3 minutes because there's a group of people waiting in line.
That's a long
And
time
you
you're
have-
giving you.
No clue what you're even looking at. You see a dot. Oh, okay, that's great.
Yeah.
But to be able to have a big screen, have a lot of people gathered around, and you doing exactly what you're doing here on a stream, explaining everything, and pointing out different objects. It's just mind-blowing. I think it's just so perfect. That's what we need to do.
I think so. And I think it's a great idea. Okay, 325. Let's do 30 seconds. That's it. I'm not going to go to 45. I don't need to. All right, and we'll come off of this guy. 325 is a good setting. We'll go to our live stack and remove the last stack that we saw. Clear that. All right. And now we are going to check out the Andromeda galaxy. But before we do that, we want to make sure that we get rid of that. We don't want to hyper process. Okay. Get ready, folks. Gonna knock your socks off. You sitting down? Here we go. Kapow. Look at this. Look at that. What a beautiful galaxy. And I'll check I'm going to set the color straight right now. So here's a color correction. Look at that. Look at that. Now, where else do you get to see this live? I mean, you just don't see this live anywhere. You know? Not only that, we have the ability to zoom in on this. We've got this big field, but we can zoom right into a little tiny spot. You know, I was thinking, Daryl,
Sure.
there's another astronomical camera that can actually give us more pixels and do the same thing this camera's doing.
Oh.
And so I'm wondering whether that might not be a good camera to use, and then take this camera that's on there now and put it on the other telescope. Yes, there's going to be another telescope in there. I'm just wondering. It might be a cool idea.
Well, if there's going to be another scope, you're going to need another camera.
Yeah. Leslie Latin Taylor, welcome. Haven't said hi to you tonight, unless you just started talking in the chat. It's nice to see you. Yes, we'll need another camera. And Marianne is still out there wondering, what camera? What are you talking about, camera?
Oh, I'm just listening. You figure out what camera you need, and we'll get it going.
We'll make it happen.
I need some new prints for my art room. So
that's true.
I'm waiting for some new prints from this new camera, and if there's a better camera out there, well, I'll be waiting for those too.
Yeah, I have to look through and see. I'll have to look through and see.
Now, quick question: the images that you're copying and you're putting on the server, that you're saving and putting on the server, are they ready? So if somebody takes one off the server and wants to go get the print made, is it ready, or does it need any more processing?
Oh, they could always use some more processing, but
Okay.
see, I'm doing processing right now as we speak, and I save them exactly as seen. So, for instance, right now I'd like to make the background darker. So I'll slide this little slider, and you'll see the screen get a little darker right there. Vera Lucia, thank you so much. That's so kind of you. I like the little animations, Vera.
Vera,
Thank
you're
you.
so
That's
cool.
very sweet.
That's neat.
Thank you. And Dave Schmidt asks, what is the, I missed it here, what is the dark streaks, like partial rings? Are they empty space? Are you talking about these dark streaks here? These are dark lanes. These are actually dark dust, David. there's a lot of dust in galaxies because dust is made by supernova explosions and by red supergiant stars. And that dust a lot of times can be molecules of carbon. There's a lot of carbon-carbon out there. There's 2 carbon atoms connected. And they can make chains of other things too. You can get amino acids out in space. You can get additional compounds. Some of them are organic type compounds and some of them are not. And so the dust that's made is interstellar dust. This stuff, when it gets big enough to be seen, it's going to be a tiny piece of dust. Multiply that by billions of trillions of pieces of dust, and you end up with this. And this dust was made in the outer atmospheres of these big stars and in supernova explosions. So galaxies are literally littered with garbage, debris from stars that have long since passed. At the beginning of the early universe, there wasn't a whole lot of dust because there wasn't a whole lot of carbon at all. In fact, very little. Almost all the carbon we see was built in the hearts of a star at one point. And when stars undergo hydrogen fusion, that means that the 2 hydrogen atoms are slammed together, they make a helium atom. In reality, it makes isotopes, but don't worry about the details. Hydrogen makes helium, but then helium can go together to make carbon at higher temperatures. And carbon can go together to make nitrogen and oxygen and fluorine and magnesium and calcium and phosphorus, and every element in the periodic table that we have was made in the heart of a star. Okay, except for the laboratory created ones, and even those might be made somewhere in the universe. So it's pretty cool. So it's dark dust that we see that comes from all of that.
As I mentioned earlier this evening, when we were looking at Indice 253, the tips of the ends of the galaxy, so to speak, in this picture here, at the upper left and at the bottom right, how blue they are compared to the rest.
Yeah, that's where I was going to. I had a feeling you were going to talk about that.
Yeah. Again, I think it showed up in both galaxies, even more so here with Andromeda. And Andromeda being closer and bigger and brighter may be part of that. But as you said before, I guess there'll be associations, or at least the big bright patch there right now.
Yeah, this is one here. Then you got one right around here. This is this red thing is I believe a pixel issue that I have in the camera. Don't worry about that. But you got this beautiful red. You got this beautiful blue area, and it kind of wraps around right here. This is an area of intense star formation. Don't expect there to be too much life in this region, because there's a lot of very high intensity stars here that have a lot of high intensity ultraviolet wind, stellar winds, and those stellar winds are absolutely sterilizing. So carbon-based life, the molecules that make up carbon-based life, would be destroyed by this ultraviolet light. So that's what happens a lot of the times here. But there is hope, because out in these spiral arms there are areas that are shielded from that. Hey Martian, thank you. So he asked a question. So what's your favorite galaxy outside the Milky Way? Well, I think we're looking at it, Martian. We're looking at the Andromeda galaxy. Look at all the detail. Look at all the incredible detail in this galaxy. Look at these little tendrils of dark dust that we're seeing as they were 2 million years ago, because that's how long it took the light to get here from there. Isn't that incredible? But it's just
H2 region in that dark cloud to the upper left of the big blue one.
Yeah, well, there's this one here. That's what you're talking about.
Right there, yeah.
Yeah. Well, there's one here too, if you notice.
Yes.
Okay, there's a big one there. And there is another one. Let me go to it. Okay, there's one right here.
Say thank you to Leslie, too, Mark.
What did Leslie... Did I not thank her?
Did you?
Oh, Leslie, I thought I thanked you. I am so sorry. Thank you, Daryl. Thanks, Leslie. I missed that, I think. Thank you so much. I'm not always looking at the chat. I have it up, but I have two screens. This screen is the live view into the observatory. This screen is the production view that has the chat here, the view there, and a smaller window of everything that's going on, plus all the volume controls, music controls, things like that. So I tend to sometimes miss going left to right sometimes. But thank you so much. That's very, very kind.
Mark, I'm sorry,
Yeah.
Go ahead.
No, I was going to say, I'm not talking, Daryl, until you talk.
Go ahead, please.
Okay. This is another beautiful H2 region, and there's actually a hot blue set of stars in here that look like they're powering it. And there's more blue stars here, more amazing star formation happening in here. And every one of these little tiny red areas in here, these red areas are probably not stars. They're probably little nebulae in here. Now, I don't know that for sure. I know that this is a nebula. I know there's a nebula here. Okay? But look at how stunning this is. I mean, this is pretty clear. You know? We also have a very, very red nebula up here. That's in here. And then more star formation with a nebula within it. I mean, this is just an exceptional area. And this end of the galaxy is more prolific in formation than the other end. There's a lot more going on at this end here. There's so much going on in here. All right, so Daryl, I'm sorry. Go ahead.
That's a beautiful area there at the... you just went out of frame with it.
Bring it back.
Well, that bright spot there, upper right quadrant, that right there.
Yeah.
Per what David Schmidt was asking about the dark lanes, and me going on before about density waves, I mean, what is forming, what is corralling the dark lanes? Density waves?
I imagine so. And now let's explain what that is. When stars orbit in the galaxy, they all orbit independently of the spiral arms. You'll have stars that move into the spiral arms and move out of the spiral arms. But there's a lot of star formation that occurs in those spiral arms, because that's an area where there's a lot of focus and concentration of material. Gravitational strength is there. Attractive forces are there. So stuff is actually kind of forced to hang in there a while as it orbits the galaxy. Well, the longer it hangs in there a while, the more it interacts with other things gravitationally, causing shock waves and star formation and other things. And when stars form there, well, then they tend to die there. They tend to explode there. And so when they reach that red giant phase, they tend to slough off their outer layers too, and do a process called mass loss. But the really, really big ones will go supernova, but not before they distend their outer envelopes so big, so far, and such a large diameter that the outer envelopes can actually form molecules of carbon or some such. And so that will be basically soot in the outer atmosphere of these giant supergiants, red supergiants. And that soot ends up hanging out in the interstellar medium. Okay, you see some right here. You see some right here. You see a tendril of it right here. Okay, you see it in every one of these dark lanes here. You can see like a tendril right there, right there. So there's this stuff everywhere you look. So in the dark lanes tend to outline the spiral arms or be part of it, because that's where the stars are dying. And when they blow up, a lot of this dark nebula, a lot of these dark dust lanes are made in those supernovae, and because of the evolution of the stars. So they tend to hang out there. But it's not constrained only to those, as you notice, because even in the Andromeda Galaxy, we can see that there's some dark lanes here in the middle, too, of this galaxy. It's not just along the outside, right? They're more pronounced on the outside, okay? But now let's consider what it is that we're talking about when we say a dark lane. Or a density wave. I mean, when Daryl mentions the word density wave, he just says it, but, how do we characterize it? How do we define it? We can define it from a traffic helicopter flying over a highway. And now you're going, what? Okay. You're in a traffic helicopter looking down, and, you get the news report. Well, we're flying high over the interstate, and we can see a whole bunch of cars that are bunched up in this traffic jam. Okay, and the cars enter the traffic jam. Let's say there's a red car. It enters the traffic jam. It slows down. It starts to go very slowly, and it moves through the traffic jam eventually and goes on. But the traffic jam is still there. It's just different cars coming in to form that knot of cars before they get through it. But there's more cars that come in to take the place of the previous cars. Just because you get through the traffic jam doesn't mean it's not still there. It may very well still be there. Well, the traffic jam is the spiral arm. Okay? And they move just like traffic jams move. Okay? When a traffic jam is moving slowly along the highway, that's a spiral arm that's moving slowly in the galaxy as well, but it moves at a very different rate than the stars move. Okay? And so we have this process ongoing in galaxies. Many people will call a density wave almost like a standing wave. It's not really. It's there as a feature of this particular process going on in the galaxy. All right. So that's what we mean when we say density wave. Density wave theory is the process that is adopted to explain why spiral arms exist at all. Otherwise, in a galaxy that has spiral arms, you would expect the galaxy to wind up and all the spiral arms get very, very tight until they're all gone. And we don't see that. We see galaxies that have big, wide open, loosely spiraled arms, and that's because they pretty much stay where they are, and the galaxy rotates, the stars rotate around or through them. So just like a traffic jam, spiral arms don't always have the same stars in them. But that's where stars can be formed, and then through gravitational interactions and the fact that everything is moving, they will begin to orbit and move around the galaxy. So that's kind of a little primer on this whole density wave concept. So they're not, when you look at a spiral arm, it's very tempting to say, look, they're moving, they're sweeping out all this direction, all this motion, but they're really not. And that's kind of the hard thing to fathom. There's a little motion, and near the middle they might move a little faster, near the outside maybe a little slower. But in general, another tough concept to swallow is the fact that when we look at a galaxy like this one, all right, and I'll just zoom out to show you once again. When we look at a galaxy like this one, it's hard to believe it, but the stars moving around the center of this galaxy and the stars moving around the outside of this galaxy are moving at very, very different rates, but not so different from each other that it doesn't appear that this is moving as a solid disk. It actually acts, the rotation of galaxies acts more like a solid disk of rotating material. That means the stars out here are moving a lot faster than the stars inside. Okay? So you see, very different rates, but for different reasons. Normally you think things near the center move faster, like Mercury goes around the sun in 88 days. Pluto takes well over 230 years to go around the sun. So, farther out in the galaxy, don't stars move slower? No, they actually move faster. Ah, man, that's a head explosion mechanism there. Okay, that's a head popper. But the fact is, okay, Daryl, I'll get to that. The fact is that the galaxies move almost like a rigid disk. So the stars inside move at one rate, and the stars outside move at a similar rate, but they're different. It's different rates. There is not a one-to-one motion there. Okay, so that's a whole nother thing, and that's where the concept of dark matter comes from. Dark matter that actually helps the galaxy move as a rigid disk. Okay, but that's for another night. Daryl, what did I miss? I'm sorry.
Isabella has a question for you. Scroll up a little bit. Mark,
Okay.
do you think that...
Mark, do you think that you could be quiet once in a while? Oh, that wasn't her question, was it?
Mark, do you think that there are habitable zones in the galaxies too? Like closer to the center, better than farther away? What I was saying was, you've alluded to that the blue areas, like where the OB associations are probably not life friendly due to the radiation from the hot blue stars. The red areas might be... Go ahead.
Yeah, you're on the right. You're exactly right. Is my view, Daryl.
Yeah, the redder areas where the H2 regions are, or the more mature areas of the galaxy, are probably friendlier to life. And then Isabella asks, what about closer to the center? Well, that's where older stars are, and if you got too close to the center, where there's supermassive black holes, that may not be such a friendly place either. But the blue areas are probably the hardest on life.
Yeah, and keep in mind also that the older the star, that means that it was formed in a stellar nebula that was less rich, potentially, in the materials that would build planets. Okay? So we have a sweet spot of all this stuff in the universe. The sweet spot where stars form with a plentitude of materials in their atmospheres and in the nebulae that form them, like the Earth's solar nebula. Okay, the Sun's nebula that formed had a plentitude of elements from many different stellar explosions across the billions of years that sort of ended up forming this one nebula where we were formed. And if it happened here, it happened elsewhere. But as you pointed out, Daryl, these areas here are probably not as good for life as a different area. Like this area right here might be a better area because there's stars that are probably rich in those materials that make up a place like the Earth and the other planets in our solar system. Areas like this up here. Go ahead.
Well, the blue areas too, they're younger. And they probably haven't had time to evolve life at any rate.
Exactly. That's where I was going to go to next, is to say that these younger areas, however, aside from being rich in ultraviolet radiation, have also not been around long enough to allow for mature planets. Guess what? Some of those stars, say from like the A stars on, we have O, B, A, F, G, K, and M. Well, the Sun is a G-type star. And there's a lot of G's, a lot of F's, a lot of O, B, A, F. There's F's, G's, K's, and M's in plentitude in the universe, and relatively few O's and B stars, and there's a reasonable amount of A's. There's fewer of those previous types, but it's those previous types that seed the universe with many different materials predominantly, and then it's the stars like the Sun and lower mass that do those things like the Helix Nebula, the planetary nebula. That cloud of slowly moving stuff will go out and eventually, potentially, form the seed of planets and stars elsewhere as it disperses. So there's a sweet spot, there's a sweet spot of when we'll be able to see stars that can form, that have enough materials around them, okay, to form planets and possibly life-bearing planets. And as we found, we've found there was many different places in the universe right now that we found that have planets that are as old as 12 billion years. She's 3 times the age of our 2.5 times the age of our Earth. So if there was life there, it may have long since left the planet. You know, if you look at how fast technology is developed here, we have developed probably, oh gosh, I'd say that, you know, we went from the Wright brothers learning how to fly to walking on the moon in basically 100 years. Not even, right, in terms of technology. And it's less than that. So the fact is, that's a drop in the bucket. So effectively, it's a splash in the universe. And we went from earthbound civilization to a moonbound civilization. And we've explored all the planets in our solar system. You know, and that's pretty cool. Next, we'll be exploring the Kuiper Belt and the Oort Cloud. We'll be out there. And we'll get out there someday. And the thing is, as far as we're concerned, we have time aplenty. So, it's just an interesting set of concepts. And when I see a galaxy like this, I cannot help but just think about all the many possibilities. Just can't help it.
You know, one thing that people get wrong a lot that just slays me, they're talking about the future and living out in space, and they start talking intergalactic. And the difference between interstellar, you know, like if we were living out in the stars someday in the future, like on Star Trek, the difference between interstellar and intergalactic, you're talking a millionfold difference, you know. I mean, you're probably a godlike being if you can move intergalactically. I guess they did that on Star Wars, but the scales are just so different.
Yeah.
What I find interesting in what you're saying, you know, you go back and you look at globular clusters. Those are some of the oldest stars in the universe, and they're saying globulars may be 13 billion years old, but they're metal-poor stars, and they don't have the building blocks of life.
That's what metal poor means, guys, so you know.
Yeah, you need mature stars that have all the heavier elements in them and all that happy stuff to make solar systems, stellar systems, to give us what we need to live. And you'll find those better in red areas than you will in the blue areas, because A, the blue areas, the radiation will kill you, and B, they're so young, they just haven't had time to spawn life anyway. Maybe when they cool down and turn red later, that they'll form life there too. Except the blue stars tend to burn so hot and fast that they blow up before life can ever form in the first place.
Right, and that's the thing to look at down here when we look at this. This area right here, this is a hot set of O and B type stars, possibly. This is, they call them associations because there's so many of them there. And it's the interesting location. Well, they formed in a nebula of sorts, and their hot gases, their hot radiation, has dissipated that nebula. So you don't really see much of the nebula here. Okay? When you have fewer stars form of lower mass, then you get things like this over here. You get a nebula there where you have a singular star or a little group of cluster of stars that's actually causing a little tiny hydrogen patch to glow, like the Orion Nebula. That's the Orion Nebula, for instance. Okay, so, but here, these stars, they live their lives fast and furious. And they'll make hydrogen into helium, helium into carbon, carbon into nitrogen, oxygen, all the way to iron, number 26 in the periodic table. And that's as far as they can go. Because to fuse iron into anything else, you need to put in more energy than you get back. And the whole concept of fusion is you put in some energy to make hydrogen into helium, but you get a lot more back. Same thing all the way to iron with all the successive fusion processes. So iron ends up being the last place you can go. And you'll say, but wait a minute, iron's 26. We have like 100 and some odd, 118 elements in the periodic table. Well, some of those are made by humans, but it's only a small fraction. What about all the others? Well, those come from a number of different processes. There are ways in which stars like our sun can make some of those other elements It's a very slow process, but as I've said many times, the universe has time on its side. And it's a slow process of decay, for instance, that can make, say, an atom of, magnesium in the sun or in a star like the sun. And it takes a long time for that to happen. But, again, over billions of years, you can get an awful lot of that material. And that's called a slow process, the S process. And then there's a fast process, which occurs when stars explode. And then during that fast process, where you have iron in the core of this big, heavy, massive star, 30 times the mass of our sun, that that star, when it explodes, spontaneously makes a bunch of new elements as it does so, and those things go bam, 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 and spread out into the interstellar medium. And so we have that process going on too. So the universe is like a big factory, an element factory. That's what it is. Stars are element factories, and supernovae are super factories for elements. Okay, so that's kind of what we look at when we look at the universe. It's a big element factory. And that's what we are. Just a pile of elements. So that's pretty cool. That's how that works. And the dark dust forms there's a lot of materials in there that can form planets and so forth. More than just carbon. We've got iron in there. We have molecular iron. We have atomic iron, rather. We have other elements. So there's a lot going on in these dark nebulae, and sooner or later they can condense and form a star again, or a star with a disk of planets around it, and we've seen that a lot. So the universe is kind of like a big nursery for life in some ways, and as Daryl said before, these blue stars are not the place where we want to hang out, at least while they haven't gone supernova. But it's after they go supernova and after that material spreads out into the interstellar medium that they can start to form new stars and new planets and possibly new life.
Exactly.
I like that.
How many exposures are we up to now?
Oh gosh, we're at 61. That's the most we've ever stacked in the Andromeda Galaxy, so I'm going to stop it here. This is going to be a gorgeous photo. This will be a barn burner. This is going to be great. So let's pause this. Save it. We should, if we're doing this one, see, this is called an SB. This is a fairly tight spiral arm structure. But, we should actually look at a galaxy that's got a very loose structure to it. And I think Daryl knows exactly what galaxy that would be.
Oh,
it's not too far away.
Yep.
Won't be too hard. Marianne, you still awake?
Well, yes, but I was just sending you guys all a note saying I am going to go ahead and just sneak on out of here tonight.
Okay. You know what? I'm sorry for dominating the last little while here, but
no.
There was so much that had to be said. I apologize.
No, gosh, don't ever apologize. That was an absolute amazing explanation, and I just learned a lot. I just sitting here just amazed on everything that I'm learning. So don't ever apologize. You're doing a great job. You and Daryl are amazing. So I thank you for everything you're teaching me.
Well, I want to thank you for joining us tonight. Again, as one of our benefactors and primary movers on SkyTour LiveStream West, you guys, show her some love. This lady has done more for us than anyone. And right behind her is Tara Diulis, who is also the artist who did the door for Observatory. And she served as the foreman to actually oversee construction of the building when I couldn't be there too. So let me tell you, these two ladies are of paramount importance in this organization, if you call it that. So I just want to thank you publicly, make sure everybody knows that the I in SkyTour LiveStream left a long time ago, and with Daryl here as a co-host, you all love the guy. You love what he says. You love his interaction. You love how we talk back and forth. You love our different approaches. And that's what SkyTour LiveStream is all about, you know. So you guys have to stick with us. We're not done yet for tonight, by the way. Only Marianne is done because she's a wimp.
I am. I'm sorry. I apologize. But hey, thank you again, everyone. It has been so wonderful being here with you all. And Isabella, you're going to be the next one as the guest co-host. I guarantee you that. We got to get you on.
I asked her. She said she doesn't want to do it. I you know what?
Oh, now we got to get her.
If she doesn't speak English too well, then that's okay. She says she hunts for words. I get that, and it's nothing embarrassing.
No,
I mean, don't forget, Isabella. I toured Norway, and I had to speak to Norwegian audiences. I don't know Norwegian. Okay, so I had to figure that out. You know, so I don't. That doesn't. You get some sympathy from me, but not a whole lot on that. I think you'd be pretty good at that. I think you'd be, because you do some really good processing, excellent processing of our photos, and you take care of documenting every stream for us, which is really amazing. And I really want to give you some time in front of people so they know who you are.
Oh, heck yeah, definitely.
Marianne, you take care and have a good night. Thank you for coming on.
Oh, thank you, Daryl, Mark, and good night, everyone. I see you on the next stream. Good night.
Okay, Marianne. Good night.
I'll be right back.
All right, I'll be right here. Okay. It seems like every time he goes away, we go to a new place, and we're going to. All right. Right now, we're going to go to this galaxy here. It's almost directly overhead. It's going to be even better looking than the Andromeda Galaxy. But this one, this is called the Triangulum Galaxy. It's a spiral, but it's a more loosely wound spiral. And it really, really looks phenomenal, as you'll see. It's a little smaller in size than this galaxy, the Andromeda Galaxy, but it's still pretty good. I'm thanking Marianne. So that's the star we're centering on, and then we're going to go to the Triangulum Galaxy. And when you see this one, Isabella, I would never laugh at your English, because nobody laughed at my Norwegian. Okay? In fact, they thought it was really nice that I was trying to speak Norwegian. So all you're going to do is make more friends, not less. I promise. Unless all you know is the swear words in English, then that won't go over too well. But we'll love to have you on. In fact, I know Daryl would love talking to you because, you know, you spent a lot of time working on things, and Daryl just loves what you're doing. You've got a whole website that you've made, which I want you to tell people about. It's really wonderful. You've done such a good job. All right. Well, there's that galaxy, and we're gonna let it do its. We're gonna take the telescope, find a guide star, and then we're gonna come in and do a 30-second exposure. I think will be good for that too. 30-second exposure. I'll wait for the guide star, and then we'll come in with that. Okay, we should have our guide star by now. So off we go and get out of the hybrid view and go into our stack. We'll clear the Andromeda Galaxy. And we're going to pin this because this is going to be a beautiful photograph. I may have to just do some color setting and so forth, but you ready for this? This is a loose spiral, so it's going to have arms that look kind of disheveled. Okay, so look at that. Ready? Look at that. Wow. That's incredible. And that is Measure 33 in Triangulum. It's the Triangulum Galaxy. This galaxy is just a little further away than the Andromeda Galaxy, but it has so many nebulae and so many things in it that we can see from here that they have their own names. You know, we've named nebulae inside other galaxies. It's really cool. Yeah. Mindermo would like your website, Isabella. Please post your link so people can go check out all your photos. Okay. So let's go zoom in a little bit here. We're at 75%. We're at 50% now. Look at that. Wow. I'm going to zoom out just a little. I think Mind Remote wants your website. Okay. So here, if you look, you see this. This is an amazing nebula structure right here. Okay, and a big giant stellar nursery, probably the size of what we call the Eta Carina Nebula here. Absolutely amazing. And then this one here is another one of substantial size. Just incredible. And then we'll see these green objects here. See those green objects? One there, one there. Okay. And then down below, there's several others. There's another one right here. And that one actually has detail in it. These are very likely supernova remnants in this galaxy. And that's not mean that's all the supernova that occurred. Many supernovae have occurred here. Cool. This looks really pretty, Daryl.
Ah, M34.
-1.
M33. How come nobody ever hears about M34? What the heck is M34 anyway? I'd have to look that up.
There we go. M31, M32, M33, and then M34 is just lonely.
I'm gonna do that. Hang on.
All right.
I know where M35 is.
Yeah, that's in Gemini. It's a beautiful open cluster. Actually, we can probably look at M35 tonight. Probably up enough now to see it. Wow. Look at this galaxy.
There?
Yeah, I'm here. I'm just waiting. I'm just watching things come in.
M34
So did you look up M34?
Yes.
Oh. And it's sitting there going, yeah, I missed being really impressed by one number. Maybe we should give it some attention and go to M34 and just to see what it looks like so people can say.
When you're done here, Perseus is up.
Oh, we got a ways to go. And this one, anyway, this is beautiful.
Oh, yeah. Sure. Yeah, boy,
I want to show
flies.
you as... Yeah. I want to show you as I was showing other people.
Okay.
Okay, watch this. Okay, when you get in here, this object here, NGC 604 here, right?
Yes.
That, look at the detail in this. You can see detail in this. It's just amazing from 2 million years ago. Because that's how long it took the light to get here. And then here, supernova. Okay.
I'm surprised an O3 region could be that big.
Well, I think it's a supernova region like the Veil. Okay.
Yeah.
And so we're seeing a lot of that O3, but we're probably not seeing the H2 in here. But there might be, because maybe this telescope isn't showing it as well as it could. Because I am passing O3 through this filter, but it's not. It could be that it's dominating. You know what I mean?
Well, sure.
Well, for instance, in the Veil, if we go to the Eastern Veil, you look at the Eastern Veil, it's mostly O3 dominant. And the Western Veil is mostly O3 dominant. You have mostly that greenish blue oxygen that we're seeing lit up. So supernova remnants predominantly are going to maybe have that. So we're seeing a lot of that here. But I'd love to be able to have a higher focal length to just examine this. Look at these beautiful shapes of that.
Yeah.
That supernova remnant there. And then down here, the other one I want to show you. Okay, there's another one way down here. And look at that one.
Yep.
It's got a beautiful shape to it.
Yep.
Wow. Just crazy. And what's that?
Oh, that just, like you said, more focal length, more power.
Yeah, more power. Oh. That's right. So I'll go to 50% to make this fit better. And now you can see the entire galaxy. You can see what I was talking about by the spiral arms that are the capital S, little c, okay, as opposed to capital S for spiral and then little b, like the Andromeda Galaxy. This is an SC galaxy, looser spiral arms. Messier looking. Not as in Charles Messier, but just messier as in not kept up well.
No pun intended.
No
Or maybe
pun
just
intended, but
maybe just a little bit.
maybe just a little. But let's just take a
Yeah.
look. See, now we've got 16 stacked. Here, let me just go to 200%. Okay.
I've said before, I mean, M31 and M33 have doubtless interacted in the past, and you know, you've got so much star formation going on here. I wouldn't be a bit surprised if interaction caused that, and you know, distorted the galaxies too. We've talked about all that before.
Yeah, I've mentioned, folks, and to Daryl, as we both said it, and when you look at the Andromeda Galaxy, it looks like the disk is warped a little bit, and we don't know that that's really true. I haven't looked at any studies, but we do know that galaxy disks do get warped. So they look like this beautiful disk, but sometimes at one end they'll actually go down or they'll go up. And a case in point is the galaxy Messier 51, also known as the Whirlpool Galaxy. That has a galaxy that it's interacting with right at its one end, and that is warping the disk down to the galaxy, down to that other galaxy. So that the disk that should be like this is like that, because there's another galaxy down here. And when we look at it from the top, as we're looking at it, it looks like it's just sort of a tail with an extra piece on it. Well, it's actually down here in 3D. It's actually down below the galaxy, pulling that disk of the galaxy down. So it's really interesting. You know. Okay, let's go to 100%, or no, we'll go to 75 here.
Did you see that article? I think I sent you one about a supermassive black hole in Leo 1 dwarf galaxy that's one of our satellite galaxies.
Yeah.
I thought that was interesting. Yeah. It's comparable in size to the one at Sagittarius A star, and maybe it'll merge.
The center of our galaxy.
Someday, yeah.
Wow. Well, they make the merger of black holes makes tremendous gravitational waves, which can be seen a universe away, and we've seen that. So that should be really interesting. Yep. Yeah. This is nice. 21 stacks so far. Oh yeah.
I'm a big believer in Occam's razor.
Yeah.
Simplest of competing theories should be preferred to the more complex. I would almost think, if I wanted to believe in dark matter, that black holes would fit the bill. Some could be primordial black holes.
Except that black holes, unfortunately, are spot gravity, and they're spot mass. We're talking about a disk of a galaxy rotating almost as a solid disk, and black holes can't explain that. And it's more like the dark matter was thought up as an idea, because the dark matter would be permeating all this material. It would actually be throughout all of it, spread like a veil. That's the whole concept. And you know what? I think of it as a placeholder as well as you do, to maybe something we don't understand. Dark energy more so. Okay, because dark energy is supposed to explain why the universe is actually accelerating as it expands. When an explosion occurs, there's an initial acceleration outward, but then everything starts to slow down, right, as it collides with other stuff. Well, we don't see a slowdown. It's actually accelerating. So that means that the expansion of the universe is accelerating. If that's happening, how can that be? Well, you see, you don't talk to astronomers about that. You talk to cosmologists about that. The astronomers tell you what that is in the sky. The astrophysicists tell you how that thing could possibly work in about 5 different ways. And the cosmologists tell you how it's even there in the first place.
Yeah.
Or what.
Well,
so,
that's why I like Sabine Hassenfelder. She's on YouTube, folks.
Sabine is great.
She plays, Doubting Thomas or Devil's Advocate a lot, and she was talking about dark energy in one of her vids I watched recently, and she sounds doubtful too, and she started talking about anti-gravity in one of them, how it may be a complementary, basic universal force like gravity is, and where it comes from. And then she gets down into particle physics and quantum mechanics and stuff, which starts going over my head, but it's interesting to think about.
Wow.
Ultimately, though, I look at all that. Can I touch it? Can I put my finger on it? No, I can't. So I don't lose sleep over it.
Yeah, I get it. Well, I've gone full screen on this because it's just getting prettier and prettier and prettier and prettier. Again, you just don't get to see this type of thing. We're building this image. This is live. This is a live image of a galaxy over 2 million light years away. All the light you're seeing right now took 2 million years to get here. Right? So the ray of light that... What's that?
I thought it was about 3 million light years away.
Oh, I said over 2 million, so whatever the actual distance is. But I mean, let's just see what Stellarium tends to say. I thought it was like 2.7 or something. Let's see. Yeah, 2.72. So, and that's, and so Andromeda Galaxy is about 2.2 or something like that, or 2.3 or whatever. So they're well within the range of each other.
I like spiral arms.
Yeah, spiral arms are beautiful.
The one that runs from about 6 o'clock below center over to about 3 o'clock, all the chunks in that, including your green areas there and Then over at about 9 o'clock, there's that one chunk out there. It looks like it's floating all by itself. That right there.
Yeah, right there. That's a continuation of our NGC 605 arm.
Yeah. 604.
604, sorry.
Yep.
Yeah. Yeah,
All
this
that
is
right there.
Yeah, look at that. I mean, it's almost
That's
like
probably, yeah. That up there is probably a continuation of the same arm that's at 3 o'clock.
Oh,
Maybe.
yeah.
I mean, I see
Well-
two main. There are branches and spurs and stuff there, but
I see it
I
because
don't
we
know
see
how
this
many main
and we see
spiral arms
that.
do you see?
Oh gosh.
I see two, maybe four.
I see one. Okay, let me. Easiest to see it when you zoom out. So hold on. Let me take us back out here and let's go to 50%.
Sort of like
Okay.
you said about life in the past. I mean, if you take
Mm-hmm.
a critical look at galaxies, a lot of times they tend to be sort of bilaterally symmetric. But if you split them down the middle, you'll see the same things on both sides.
Yeah, just mirrored.
Yes.
So if you look at this galaxy, you see,
I see four.
one,
I see two bright ones.
2, 3, 4, 5. These are spurs including 6, 7, 8, 9, 10, 11, and then 12, 13, 14. There's at least 14 arms plus spurs in this galaxy.
Yeah.
But
if you look at
there's one line, there's one here that I know people you can see, but you can see all these different elements here. Actually, you know what, Daryl, we can do this. I can actually do some processing right on the fly here, and that'll actually make them look a little bit brighter. Let's try this.
I look at from the center of the galaxy, it looks almost like a barred spiral to me. The bar is
Yeah, I
running
agree with
from
that.
10 o'clock to 4 o'clock, and
Yeah,
out at the
I
end
see
of
that.
each of the two bars are the two brightest spiral arms,
Yeah, I see that too.
and all the other ones are, just along for the ride. I don't know,
Or spurs.
or spurs.
Okay.
Is M30 to be considered a barred spiral?
No, it's considered an SC. It's not considered a barred spiral.
Okay. It looks sort
but
of
I
like
definitely,
barred spiral to me.
it does. But then in this view, you can see how this nucleus is actually rather condensed into a spherical shape here. The way I had it processed earlier, it looked like there could have been more to it than that. So if we do this, okay, now it looks like it could be a barred spiral almost.
Uh-huh.
And let me just take down the brightness a little bit. Okay. All right. So we'll come down to this. Yeah, Skunk Ape, yes, this is just a view into the past, because the universe is a giant time machine, but you can only go in one direction, into the past. You look at our sun, it's 8 minutes old.
Yep. I mean, when you call it time travel is when it gets to be, we're traveling through time. We're traveling through space-time, and
Right.
that arrow seems to point in one direction only.
That's right.
From the past to the present, toward the future.
That's right. That is exactly right. Holy cow, this is just beautiful.
It is.
We have stacked 40 images. So I'm going to stop this now at 40. I wonder what it would be like if I could stack like 100 images. There's a diminished return when you do that. And 40 is probably the upper limit for this guy. Let's save it exactly as seen. So if people want to take this down and just get this beautiful shot, they can.
Don't leave yet, though.
I'm not leaving. I'm not going anywhere.
Can you open up the view again?
Yes, I can.
That area down at 6 o'clock toward the very bottom.
Okay, let me get rid of the object ID. Down here?
Yeah, that. Imagine the view they must have of the galaxy from there. Must be grand.
Well, that is a beautiful thought. I just think that's kind of cool.
Yeah.
Let's go to 100% and look down at that lower portion of the galaxy. Now, first of all, as we talked about, and as obviously you know, and you've been it's just because you're being, it's hypothetical. This is an area of hot blue stars. Yeah. So the prospect for life is very low.
Yeah.
Maybe not so here, though. This is an area that might actually be on the lower temperature side. It might be considered more like stars that are, more mild tempered and don't have a lot of ultraviolet energy. So maybe there. You
talk about the veil. That
yes.
There's that green semicircle back down there to the left of that area at 6
Yeah, that's
o'clock.
Is this the guy I was talking? Is this the guy right there?
Yes.
Yeah.
Yes, that right there.
And that's probably the veil of the Triangulum galaxy right here. Which is a supernova explosion. This looks like a supernova complex as well.
Yep.
Because of the filamentary structure there. We have a supernova complex here. You can see these amazing shockwave elements here pushing out into the interstellar medium. We have another one here. The smallest green ones are probably large planetary nebulae. But like that right there, that could be potentially a planetary nebula. But I think guys like this are definitely supernova remnants. Hi there, Chantel.
Hi, Chantel.
So nice to see you.
Thank you, Isabella.
Oh, did she give us the link again? Oh, thank you, Isabella. She's good. And by the way, she agreed to come on the show.
She did.
She did. Yeah, she's concerned about her English. And I was like, really? I toured Norway. I had to speak to Norwegian audiences all over Norway. Okay. So I learned some Norwegian just so I could greet them and say hello. And then I spoke in English after. Okay. So they said, I was told that my Norwegian was sort of cute. Okay. So, but I didn't let that deter me, and I kept doing it. So she'll be fine. You'll be fine, and no one's gonna make fun of you, Isabella. We admire everything that you do for us, and this is a reward for all that you do for us.
Like I said, okay. The Germans asked me to speak English, so may have been my hillbilly accent coming through. I don't know.
Oh, who knows? Okay, ready to get off this object now?
Sure.
Okay, I'm going to save it. And then our FITS file, our astronomical format. Then I'll save it exactly as seen. I may have already done this. And then when I come in, we'll be able to, well, do some more processing on that. So if you want to just get the beautiful shot, you can. Now let's get rid of this. It didn't quite go. So we'll do this. Okay. And now we'll come to 1 second here on this again. Okay. And do our hyper process. There we go. Let's do it again. And then take us to auto filling of the field. So we have the full field on the view. There we go. Okay. Let's go see if there's something of interest that's up high enough to see down here.
What about M34?
Yeah, that's in Perseus.
Yeah, we don't have to look at it. Maybe you could just take a stellarium, look at it real quick.
Okay. Where is it? Do you know where it is?
In Perseus.
Okay, that's a no.
Back,
all right.
Well, back out a little bit.
Yeah, let me just go find it. Okay. Oh, it's called the spiral cluster. Well, that's called the spiral cluster. Look at that. That's 50 to 100 stars. You know what? I do want to go to this. I'll tell you why. Because one of the things I also told you I wanted to show you was the difference between shallow and deep dives. You know that when we do SkyTour Radio, Daryl does deep dive. We call deep dive with Daryl. We go into constellations and objects deep in our sky. And we also do interesting... when we take photos in SkyTour LiveStream, sometimes we take real deep dives in everything that we do. And in most cases, you don't get to see what else it looks like, you know. And that's what we'll do tonight. I'll just show you that real quick. Hey there, Phil Sawtell. How are you? And yes, there is a black hole, as Daryl probably said. Yes. In our galaxy, there's a black hole in the middle. Okay.
I wondered if you might mean M33. I believe there's one in M33 also.
Yeah, I think that most galaxies probably have a supermassive black hole as their seed object in the middle. Okay, here's an example. Okay, we're gonna just take a I'll take a lower gain photo here because I want to show you something. All right, when you look through a regular telescope, okay, at something like this, all right, like a little telescope you might buy, this might be what you see. You might see a really cool, nice cluster that looks like this, all right? But if you actually take a deeper view and you can use a camera and take a nice deep view, then you see more stars, okay? So what's really hiding in the background behind all this is many more stars. And if we were to take a, let's say a 20-second photograph of something like this, right? And we look at it in our stack view as an example, then you see something very different. Okay, we're going to clear this out. Okay, so in 20 seconds, right, that cluster, which just looks like stars, really pretty, looks like a jewel box in space, takes on a different look altogether. Because then you're like, wait a minute, where's the cluster? You almost can't see it because there's so many more stars. And that's the phenomena that happens to you when you go to a dark sky site and start looking with your binoculars at, say, Orion. Okay, at our site out there, you look for Orion, you almost can't see it. There's too many stars. In the typical light polluted cities, okay, or these cities where the Bortle level or the sky brightness level is anywhere like a 5 or higher, which is too bright, you're just going to see the outline of Orion. You'll see Betelgeuse, Bellatrix, Alnitak, Alnilam, and Mintaka, and then you'll see Saiph at the lower left and Rigel at the lower right. And you might see a hint of the nebula underneath that belt of 3. That's all you see. You won't see any of the stars up north. You won't see any of the stars to the side. You won't see any of those other stars. But when you get to a dark sky site, you see so many more stars that you'll be struck with awe and you'll probably just stare. And if you had a camera, you probably won't even take a picture. You know?
From a truly
Do you remember the
dark
first?
sky site. I'm sorry.
Do you remember
go
the first dark sky site? Yeah, I was gonna say. I was asking you. Do you remember the first dark sky site you ever saw?
Yes.
Yeah, you never
I've
forget.
told the story before. I was a kid. We were fishing and camping at a lake out in the country, and I was lying there by the lake shore at night. Looked up. It was summertime, and I saw what I thought looked like a diamond bracelet. And I just marveled at it. And I learned years and years later it was constellation Delphinus the Dolphin, which is off to the side of Altair and Aquila. And when you see it, it looks like a kite, but when I was a kid, it looked like a diamond bracelet to me.
Wow.
And that was my first real memory of a dark sky site.
Wow.
When I came to Colorado, I got absolutely spoiled when I lived up in the high country because, I was like Bortle Zero skies up there back in the day, and I just really got spoiled.
Bortle Zero means no light pollution at all.
As they say, I mean, you could, on a moonless night, you'd still see the landscape lit up because of starlight.
Yeah.
For what you were saying here about like the star cluster, it's like looking at the Pleiades, naked eye from a fairly light polluted place. Most people see 6 stars in the Pleiades. If you're in a decent dark sky and you look up at the Pleiades naked eye still, and using averted vision, not looking directly at the Pleiades, you won't see 6 stars. You'll see a haze of light about the size of a postage stamp held between your fingers at arm's length. And that is the light of hundreds of stars. And then you look at it in a telescope and you'll see hundreds of stars. Maybe some say there's 1,000 stars in the Pleiades cluster.
Well, maybe we should look at them tonight. Check them out.
Sure. I assume that was M34 we were looking at.
Yes, that was.
Okay.
That was M34. It better be. And that was.
Yeah.
Okay. So, there's M34. And we are looking at it at a 1 second time frame. You can see the noise in the background change every second. The stars do not. That is why when you stack them, the star images and the detail, the dark nebula, the light nebula that are there come through, because you got the same signal coming through over and over and over. So it builds up and rises high above the noise, which is what you see as this stuff that's just kind of shaking around there in the background in the black parts of the sky. Okay, so that said, let's check out something else that's probably pretty high in the sky right now. I'm guessing that it's going to be the Pleiades. And you'll see something interesting about the Pleiades. We're almost at 1 in the morning, so we do have a pretty good sky right now. I'm very happy that it's... Yeah. That's right. It's 22:53 hours. So we won't be able to go. We won't go into here tonight. We're going to go into. I'll show you the Pleiades, because when you look at the Pleiades, this is an interesting case where we actually look at the Pleiades and say, hey, this is what you see with your eyes, and then you're going to see what you see with the telescope and in a dark sky sight. So we're going to actually just drop down into our normal view so we can see the telescope operating in there. I always have to have eyes on the telescope at all times. Martian says, is it possible for a galactic black hole to get kicked out after a merger? Well, a merger between galaxies or a merger between black holes? That's the question. Or during a merger. What does he mean? Okay, well, actually, let's think about that. Let's say two galaxies are colliding, and they have two black holes. Could they actually do that? Could they whip each other? Could one get whipped away from the other? And the answer is maybe yes. Depends on how that works. It's a question of orbital mechanics. So it could. It's possible. I'm not saying that could for sure, but it's possible. Okay, so here is the Pleiades. Now, let's take a look at what you might see if you looked at the Pleiades just with your eyes. Okay, you might see this. Okay, and this is with like binoculars. Okay, so you would this is actually way. This is actually more than you might see. You might see this star, this star, this star, that one, and that one. Maybe. Okay? But as soon as you start to increase the capability by using a telescope or something like that, now you're talking about increasing yourself to the point where you start to see, as Daryl said, this haze. Now we could go all the way with this here. This takes us up to 549. That's a huge amount of gain. Okay, and we get a lot of noise associated with it. So that's why I go down to about 350 or so, because that gives us the best overall view. So let's just do 10-second shots. All right, of this guy, and we'll stack them. And let's go in here. Maybe have to quickly delete a frame or two. Oh no, we don't. Good. All right, so now the Pleiades comes in. Oh, I'll hit clear. And actually it wasn't. Yeah, I have to resume. Here we go. Okay. That's beautiful. Very nice. It's kind of pretty, Daryl. And you're on mute.
I'm sorry. I was answering Chantel.
Okay. Look at that.
Yes.
That's nice.
Yeah, but
so
again,
you can see how many stars there are. Yeah, go ahead.
If you look at the Pleiades from a decent sky, if you look directly at it, you'll probably still see 6 stars. But if you look at it, turn your head to the side some, look at it from the corner of your eye, use averted vision, you'll see a hazy patch of light all around those 6 stars. And you're seeing A, the nebulosity you see there, and B, you're seeing a light of hundreds of stars.
That's right. Many, many stars. And the Pleiades, if we were to do a really deep frame here, which we should. We should just do like a quick frame to show people. It's not just around these stars that you have all this dust. There is dust sweeping through this entire frame. And it's just long streaks of dust all throughout this frame. So, let's just try that, just to show you what I'm talking about. Okay, we're going to do a 60-second shot. Alright, 60 seconds. And I'm going to increase the gain a little bit too, just to point it out. Alright. So there we go. Alright. 60 seconds underway, starting now. Commencing countdown, engines on. Yeah. Let's get the live stack up. Okay. So we're ready now. We're waiting our 60 seconds, which is already underway. And the Pleiades, of course, you see on the front of the Subaru automobile as a symbol on the hood ornament, basically. The symbol is Subaru, and it means unity. Okay, there's our first 60 seconds. I want to see if this is up to, and I don't think it is. Okay, and now let's go to here. See if I can point this stuff out. Okay, it's hard to see at the moment, but all right. Okay, we have all throughout this region, we have streaks of dust coming through here. All throughout this region.
What's that called? The Taurus molecular cloud?
Is that the Taurus molecular cloud there? Because that's it's basically what would ordinarily be dark nebula.
Yeah,
So
I
no
mean they used to say that that the Pleiades, was associated with nebulosity, and now they say the Pleiades is just passing through the nebulosity.
That's right. The stars of this very young cluster that we see here are passing through a dark dust cloud in the Milky Way, and the dark dust doesn't ionize from starlight like hydrogen does, and then doesn't glow red like hydrogen does, but it just scatters the starlight. And as you've said before, and I say, it's like Rayleigh scattering, where when we look in our sky, the molecules in our atmosphere scatter the higher frequency light, which is blue, and that leads us to having a blue sky everywhere we look. Well, this is blue sky everywhere we look too. It has to do with the blue sky, or the blue dust clouds rather of dark material that are scattering the blue light. In the same process that gives us the blue sky is the same process that gives us the blue nebula. But that's cool. And of course, these halos that you see are kind of a sore point for us. We don't like the halos, and we're going to try and do something about those. I am going to change the filter out there, Daryl, and see if that makes a difference.
Okay. Isabella says, why is it called a molecular... I can't talk. Molecular cloud. Isabella, it's that cloud is just like one of those dark lanes we saw in M31 Galaxy, or when we troll around the Milky Way here and we look at dark nebulas. They are clouds of molecules, not atoms, and they're probably much of it is carbon molecules. There could be
a lot of it is.
And they're cold enough. Maybe water.
Yeah, there's certainly certainly be water in there, too. And we know that there's also building blocks of life in some of these as well. So not so bad,
Amino acids.
Okay, it's amino acids, maybe, yes. I mean, that's also true. Depends where. Usually we'll find amino acids on the surface of comets and in meteors sometimes, and planets can build them. But floating through space, not sure. I'd have to figure that, see if that's possible, because they have to form in some fashion with enough molecules to actually make that happen.
Blech.
Okay, that's what Cypher says. Okay, yeah,
I
you
must
can
be
see
getting tired. I can't talk.
That's
Tripping
okay.
over my tongue.
All right. Well, let's try one more thing, okay? Because it is getting late. So we're going to stop this right now. And we're going to pause it. I'm not going to save it because we're going to try and do better as we move forward. So what I do want to do, though, is I want to take us back to our 1 second shot. Okay. And give us a little of that hyper-processed imagery. There we go. And now let's do something else. Let's see if we can take ourselves from there. I don't know if that's going to work. We're going to try it. I'm going to try and we're not up there. We're way up high in the Pleiades right now. But you see where the telescope's pointing above my head? It's pointing almost straight up. The Pleiades are almost straight up. So we're going to try and see just how far down we can go. Let's see if we can go to Bellatrix. I'm going to pick that star. And let's say go to Bellatrix. Let's see if we can do it. And I say let's see if we can do it because we might have the building roof in the way. Okay, as you can see. Oh, well, Bellatrix is going to be visible. Mm-hmm. There's Bellatrix.
I assume your intent is to go somewhere a little farther down.
That's my intent. I want to get to Barnard 33. So, if I can. As a last object. Okay. And now what I'm going to do is start up this guy here. Going to head to the east a little bit more. To do that, I first have to load us up for bear and make it a little bit faster. Okay, so we're going to go a little bit to the east. And then a little bit to the south. We might have a piece of the roof in the way, but you know what? It'll be worth the try. It'll be worth the try.
When I was out, went out for a look earlier.
Yeah.
Sirius was up. Could see the entire winter circle already, and Orion was pretty high up in the sky.
Good. Well, I think we're going to make our target for tonight just to try this out and see what we get. We might be right on the verge. It looks like we're going to be clear of the roof by just a slight margin. And that's a very, very happy day. Okay.
Orion's
so where we are now...
Meridian here pretty quick.
Yeah. Yeah, not
culminating,
where I am. Yeah.
crossing the meridian at midnight.
Yeah. So where we are now, guys, is this is the leftmost star in the belt of Orion, known as Alnitak. And Alnitak is an interesting star. It's a hot O-type star, and it's powering this nebula here called the Flame. And then we have this star down here called Sigma Orionis. It's actually a quadruple star. It's 4 stars that were all formed in the same location. And that
6
star, or 6 stars, and not 4. Okay, let's.
Yeah. I sent you that the other
Gravit-
day. I looked that up. It's a very complex
Gravitational
star.
bound. Yeah, they were called. It was called a quadruple star for years. So maybe that's a new finding, huh?
Yeah.
But so this star here, Sigma, is responsible for bathing this whole region here, this hydrogen, in ultraviolet light, which ionizes it, makes it glow red. And then you got this guy sticking right out. This is called the Horsehead Nebula. So why not just take a few shots of that before we finish for the evening? Okay, so that's what we're gonna do. And we'll do a 45-second photo. Okay. I think you'll like it. Let me just move up a little bit.
Yeah, the Horsehead's another one I think I saw once in my life. It was a
Really?
13-inch telescope with a filter on it, and I could just barely see the Horsehead.
Mm-hmm.
You didn't see the red at all. It was just black on. It was almost black on black. You could
So
see
it's just a very, very, yeah.
Yeah, you could see the nebulosity very faintly, but it was just gray. And
So you had a very faint silhouette.
yeah, you didn't see the
Okay.
Horsehead clearly either. It was just like a little black notch in the grayness.
Mm-hmm.
You could tell what it was, but it didn't look like an image.
Okay. Well, 45 seconds, and here we go. So we'll go into our stack, clean out anything that has to be cleaned out, and now you're going to see the Horsehead in all its glory. And when it comes in well, and we zoom in, you're going to see some detail within the Horsehead, which is actually pretty interesting too. I sent you the Horsehead I did the other night, didn't I? There.
Yes, you did. Yes.
Yeah. That was a
As you-
60-second set of exposures.
Yeah. As you said, the Horsehead is B33 or Barnard 33, and that goes
That's
back
right.
to E. Barnard, the guy who cataloged a lot of well-known dark nebulae.
Yeah. Absolutely. Look at this.
It's pretty.
Now that is really pretty. Let's full screen that. And let's bring that in. Let's go to 75%. Wow. Focus looks good. So now let's go back to let's say auto, see if that gives us what we want. Yeah. Look at that. So you can see Sigma Orionis over here, and it's causing this nebula to glow. You see Alnitak, which is causing this nebula to glow. And then you see these blue areas. These are what we call reflection nebulae. They're also known as nebulae that are caused by scattering, same we talked about earlier. Dust grains scatter the hot blue light from stars and let the rest of it kind of go through unimpeded. That's what we see here. And that's why we see blue reflection nebula here and here and here. Because this is part of a giant molecular cloud here. This is all in here, all throughout this, in fact, way outside this frame for many degrees in the sky. And that is the OMCC, the Orion Molecular Cloud Complex. And that's kind of what we're looking at here. This is a molecular cloud. There's H2, there's diatomic hydrogen here, there's carbon atoms, there's other elements from previous explosions by supernovae, and other compounds that are in here. So that's what's going on. Yeah, look at this, huh? And we stacked 3 so far.
That's beautiful.
Yeah, you can see some more out here. Let me get rid of the name for a moment so you can see that. You can see this over here. Yeah. Actually, and now what we can do is let's try to do some color correction. Okay, there's a slight color correction. And then let's do a proper contrast correction. Now you tell me, is that beautiful or is that beautiful, guys? Worth the wait? Yes? No? Give me a thumbs up if you think so. And don't give me a thumbs down if you don't. Amazing.
No, it's gorgeous.
It's beautiful. I've never ever seen the horse head this beautiful. The other night when I took it, I sat there like this. Oh. I was like, wow. Wow. Yeah, Isabella, I felt like it was simply unreal to me as well. So we've only stacked like 5 frames, but if we zoom in, if we zoom in here, let's go to 75% on this. It'll get better as we get more images. But look at this beautiful sweeping. Look at this brown sweeping dust in this here, and look here at this beautiful horse head. You actually have like this blue haze around this. That's actually there. Then you have this sort of this gap in here. That's actually there. Look at this little line. That's actually there. Right. Then you got this stuff. This thin veil, this combed veil of stuff. You have that there. That's there. You know.
I wonder if that's a shock
beautiful.
front.
Oh, I don't know, but sigma is very powerful, and it could be sigma that's causing over time could have been causing this right here, and it would have been the shock front of sigma's stellar winds that could be causing that. So you could be right on that. The universe is a very difficult place to truly understand. Focus is good. And then up here, we have this nebula called the Flame Nebula. Again, just a stunning nebula. Lots of detail in there. Kind of looks like a Rorschach test. And what does this spot remind you of, Mr. Mason?
A bug. I see a bug.
A squished bug on a windshield.
Well, the darkest part of the nebula, just above the, it looks like an insect's head right there. His eyes.
Okay.
Maybe at least one antenna sticking up. And then maybe one wing sticking up to the right.
Okay. Wow. Oh, Leslie, thank you. Isn't it beautiful? I'm just like, wow. It just, I'll tell you what it does. It takes my breath away to the point where I can't say anything. And I'm sure that some of you are saying, good. I know Daryl does sometimes.
What's that?
Yeah, burning tree, that's right.
What do I do sometimes?
You'd like me to be quiet sometimes. Because I just go on, and I do. But it's because of the passion I have, not because of anything else. Look at this beautiful area right here. This is probably a shock front. Okay, look at that. Oh,
Very
yeah.
three-dimensional. Yeah.
Yeah. That's right. We're seeing this in such dimensionality now. Wow.
I've said it before.
Yeah.
I'll say it again. I wonder why the flame is a different color than all the rest of the nebulosity. You know,
Part of
the
me
rest
wonders
of
if
it's,
that's a density thing.
you know, density or other elements. That's more of a golden color to me, whereas the rest of it's all hydrogen red.
Yeah.
Or the brown in places, and maybe that's what's changing the color too.
Well, I was wondering if maybe the flame is actually buried in dust. Less, more so than this stuff here. And if that's the case, then maybe we're looking at a dusty obscuration that's causing that. But it definitely looks golden.
Yeah. I assume it's being lit by Alnitak there.
I think it's being caused to glow by Alnitak. But the weird thing is, it could literally be a star as small as this one right here that's actually doing it. We don't. I'd have to look that up and figure it out. Actually, why don't you do that? Why don't you look up? Because you're probably already doing it. What star lights up the flame? It'll probably say Alnitak.
I believe it does.
I believe it's the basis of the fact that Alnitak's a certain distance, the flame's a certain distance. They're close to being the same. The flame might be a little further. Oh man, is this not beautiful?
Yep.
We see so much more now. Yeah. So it says Alnitak is doing it?
Yep.
Okay.
Additional dark gas and dust lies in front of the bright part of the nebula. This is what causes the dark network that appears in the center of the glowing gas.
Right.
The flame is part of the Orion molecular cloud complex. Now, at the center of the flame nebula, there is a cluster of newly formed stars.
Seen only in the infrared.
Yeah, they say they've been observed in X-ray by Chandra. The Chandra X-ray Observatory shows several hundred young stars. Estimated population of 800 are buried inside the nebula. And they're hidden to the light behind the dark stuff, I guess. Yes, X-ray and infrared images indicate that the youngest stars are concentrated near the center of the cluster. So imagine one day when the stellar winds, I guess, blow the remaining dust out, or maybe, roll back the dark part so we can see inside it. That should really be something to see.
Yeah, but keep this in mind too. One of the things that's interesting about this is you're worrying about the color, wondering why it's changing, why it looks gold. If you look at the way those young stars are, those are going to be hot blue stars.
Yeah.
So the hot blue light of those stars is going to cause the dust to glow blue. And in a red nebula, when you have a blue nebula, if it's a tenuous enough nebula like we have here in front of this, you might not see the blue. But the blue might change the red color to a gold.
Yes.
So That could explain the color difference between the flame and the nebula by the Horsehead. Is those young stars causing some of that, or the dust causing the light from some of those blue stars to be scattered in front of the flame? I think we solved it right there. I think it's just the blue stars inside that are scattering some of that dust and the blue light that you can't see because it's totally overwhelmed by the illumination and glow caused by Alnitak. Just a thought.
Oh, I agree with you. There are some really cool images. I'm at the wiki page for it, and including the Chandra image, where it's like they've taken an X-ray of the whole nebula. You can see the stars down in the middle.
Okay.
All sorts of neat pictures.
Look at this one. You can actually see the top of the horse's head is a different color, and this really is this way.
Yeah.
And there's many different pieces, and we've got them. We're showing it. Look at that.
Yep.
Outstanding. Wow.
Always reminded me of Knight from a chessboard.
Oh yeah, chessboard. Yeah. Uh-oh. Sorry, I just yawned. You know what that means. All right, we did 18 here so far. So what do you guys think, huh? Is this cool or what? I never imagined in a million years, that I could actually end up with a full remote observatory like this. And now, here it is, and I'm beside myself. I almost don't believe it's really here. I'm waiting to wake up to find out that it was all a big dream. And may I never wake up.
Mm. That's a tremendous image.
It's beautiful. We have some nice detail here in this nebulae. We have this beautiful detail in the flame. Great detail here in the horse head. Great detail in the area around it.
You could do quite a wiki wander just checking out all the objects in this image. The horse head, the flame, Alnitak, Sigma. Sigma has a really good article about it all by itself.
Wow. Let's look at the frame, full frame. There's the full frame, guys. And notice, in many pictures of this area, when you look here, you just see dark and then this sort of sticking out. You'd never see the mottled gradations in the dark nebula here. This is all different stuff. You can see that this is like overlaying and mixed in. It makes it much more easy to see that this is a giant molecular cloud.
Yeah. The darker part there to the left of the bright line at the horse head, it looks almost like it's being shadowed by that shock front or whatever it is. Yes, all that on that side of it. Looks like it's in the shadow of whatever that divider is where the horse head sticks up.
Yes, you mean?
Yes.
Okay. It could also be denser.
Okay.
So it's a little darker there. Wow.
Oh, that's tremendous.
22 stacked. Wow. Look at this beautiful wave here.
Yep.
Just stunning. Obviously, stellar winds from some star nearby have been sculpting this gas. It could be Alnitak, but look at just this beautiful variation here. I mean, a great image would be just this right here. That'd be just a great image right there.
Would you mind I'm going to send you a picture.
Want me to put it up?
If you wouldn't mind. I sent you this a few nights ago.
I see it.
This is the entirety of Orion, showing all the nebulosity in the constellation.
Okay. Okay, I gotta figure out how to show it. Let me... Save it to downloads. There we go. And now I can bring it up. I will just do this thing. We're still stacking, guys, so hold on a second as this happens. Now we're going to open up, go to downloads. Come on. Oh, wait. Here we go. There we go. Okay. We're still stacking right here. So as we're stacking, doing this stack, let's go take a look at this. Now, can you guys actually see Orion? Probably not. But there's the horse head. Right there. And we can show it easier by doing this. Okay. Okay.
You see,
so
see the horse head. You can see the
here's
flame
the Orion
just
Nebula.
above the horse head.
Yeah.
Yep.
Here's the Orion Nebula. Here's the belt of 3 stars. 1, 2, 3. And then here is the horse head with the flame. Yeah. And if we go up higher, we can see Betelgeuse. Wait.
Now you got to go
Flame,
higher up.
yes, right there. Yeah. Betelgeuse and Bellatrix, which is that Bellatrix?
No, that's Bellatrix. Bellatrix is below it to the yeah. That's Bellatrix.
Okay, but what's interesting is you see this. This is called Barnard's Loop. This is a very deep photo of Orion. No, this is like an Orion donut. Yeah.
And if you scroll up to the top, you can see what we tried for the other night, the Mesa Nebula, all that right there.
Yeah.
We were zoomed in so much on Mesa that we couldn't see the nebula. It's actually
huge.
We
only had these stars in there.
Yeah.
Yeah. That's very cool.
Yeah.
Wow.
That's
Thank
been
you.
That's been my desktop image for I don't know how many years. Long time. It's an old APOD from about 20 years ago.
Gotcha.
Anyway, thank you.
It's got better. Yeah, sure. Well, we're at 28 stacked, and it looks beautiful, don't you guys think? Wow. Looks so nice. Let's zoom in on the horse head now and see what we've got. Okay, this is 161%. Look at the detail in there. That's pretty good.
Yes. See real fine wisps in it too.
Oh yes, I saw that. Look at these little fine wisps. Look at these little things. Right there, right there. Wow. This is just better than anything I've ever seen. Oh, I really like this. Wow. Incredible. And again, to take your breath away fully, full frame. Does that work or what? Look at the beautiful variations in this nebula over here. You can almost see this in 3 dimensions. Wow. Daryl's muted again. That's okay. Okay.
I'm sorry. Say again.
I said you were muted. It's okay. I said you can see the wisps all throughout this whole area. It's beautiful.
Oh, I'm not muted, am I?
Oh, well, yeah, I thought you were before. Okay. Okay. 31 shots. We're gonna save it. Isabella's going, yes! Oh, I can't wait! She's going to attack this one with a vengeance. And I just say, good for you, Isabella. So there you go, folks. The Orion Nebula. I'm sorry, the Horsehead. And as a bonus, I'll try to go to the Orion Nebula. I did a number of exposures here just to see if we can actually wait out a few minutes to get to the Orion Nebula. It's 1:36 in the morning here, and I really got to go to bed. But I'm going to try this. Because I am just one more, you know, all the time. Always just one more. Look at that. We only have to go down a little bit. I will be right here. Okay, here we go. Every time he goes away, we get to a really cool object, so this is neat. Alright. Oh, Lizzie, it's okay. Well, we're actually gonna get our way down now to from here. We're gonna move ourselves down not too far, and we'll get to the Orion Nebula. That'll be fun to take a picture of. My gosh, yes. Okay. And we're only gonna do a short photo. Okay, let's just do this. Do that. Okay, that's a little too much. I went too far. My mistake. I'm just driving down to it, you know. I think that is the rubber stamp. Yeah, the 13th pearl rubber stamp. Is that in here? Probably not. It's okay. I'm not gonna stick around here too long. But we should see it. It's gonna be small in this telescope. Okay. Hey, what'd I do? I went up too far. Okay, I apologize for that. Let me just go back down. I think it's because I'm getting tired. Let's see, it did it again. We're gonna head to the west. Hey, welcome back.
Thank you.
All right. Okay. And now we're gonna go here. All right. Now, there we go.
Thank you,
The
Isabella.
Orion Nebula. Oh, thank you. I see that now. So that's the Orion Nebula. And I almost want to just do a deep shot of this to look at the extent, so you can see all the detail here. But I guess I can actually run auto right now. Okay, if I move up, we're going to see the Running Man Nebula as well. So here it comes, right up above this. Here it is. The problem is, the Orion region, because of its proximity to the celestial equator, has tons of satellites that are always going through here. So if I take a photograph, and I'll do one, let's try this first of all. Let's drop down the gain so we can see what's in the Orion Nebula. All right, so there you go. All right, and now let's zoom in on it. Right to 100%. And there you can see the trapezium.
And I see Bill Murray eating a Milky Way, or eating a Baby Ruth bar. Should have known.
You're
that was
something.
coming.
I should have known. I didn't
Can't help it.
remember.
That's what I see.
Let me try something out. Let me see if I can change the focus a little bit. Okay, 518 looks like it's focused. Let me try 418.
The trapezium is so cool too.
It is. Okay, that's
That's
a
the
little less
four
focused.
bright little stars in kind of a diamond shape down in the very heart of the nebula there, which is illuminating the nebula.
Yeah, that's powering the nebula for sure. Okay, this will work. Alright, so you see, in a telescope, you might see this much of the nebula. You know, that's what you might see when you look at the nebula. Okay? Then, if you have a bigger aperture, okay, and more light gathering power as a result, you might actually then see something a little bit more, like that. Okay, and then if you have even more aperture, you might end up with something even brighter. something like that. Okay. And then we're going to stay at 308. We're not going to go higher than that in gain. Okay. And now we're going to go and do a 30-second shot of this. And there we're off. And we're going to go do auto so we have the full view.
Is that hybrid?
Oh, thank you, Leslie. Yeah, I gotta turn it off. Thank you, Leslie. That's very kind.
Thank you, Leslie.
Okay, now this will clear. And then, boom. Now you say, yeah, that looks awful. That's because we haven't processed it. It's a very bright object. So you process it, and then you get some really cool views. Of course, I told you.
Yep.
That's what happens. Thank you for spoiling us, Mark, and stellar hugs to all the STLS. Oh, thank you, Leslie. That's very kind. Very sweet. Yeah. I mentioned satellites are going to plague these images.
Looks like a slow one, too.
Yeah, over 30 seconds it's moving that far. It's got to be a booster. It's, maybe 12,000 miles, 6,000 miles out. We can measure the length, and I could calculate exact altitude. Okay, I can get the speed and thus the orbital altitude. Look, another one. Okay. Let's just do this and just deal with it. Isn't that gorgeous, though?
2 satellites.
Wow. Yeah, I know. I said there's another one there.
Oh.
And there's a Running Man.
Arnold Schwarzenegger.
Yes, stick around.
I'll be back.
Yes. That was Richard Dawson played the bad guy in that, right?
Yeah, he was a game show host.
Yeah, he was the game show. It was Newkirk from Hogan's Heroes.
Yeah.
Yeah. That was a fun movie. Look at that.
I thought
beautiful
it was
nebula. Of course it was, but it was fun.
Yeah.
The whole point is don't take it so seriously, right? So you laugh at it. Look at that. Look at how much detail's in there. Detail we've never seen before. And then the Running Man Nebula. Amal, thank you.
Thank you, Amal.
Tuition fees. Oh, you're funny, Amal. That's great. When we take this picture at like a different site, we see this thing in this Running Man Nebula, and it's dark. But we never see the cloudiness patchwork structure like we see here. This is just incredible. Absolutely incredible.
There's an almost curdled look to it.
Yeah, like curdled milk or something. Or curdled boiling chocolate. That's so cool. And the nebula just looks so incredible. The colors aren't quite right, though, and I'll have to cover it. Vera, thank you. Vera
Thank
Lucia
you, Vera.
Campos.
Thank you, Leslie. Thank you, Amal.
Just beautiful. See, now here's the thing when you look at this, okay? This nebula here, this is more red, okay? This is more of a bluish green. We're actually looking at O3, oxygen that's been ionized in this nebula. Again, shed from stars during supernova in the past. And then we're looking at hydrogen gas that's also being excited by the stars of the trapezium, buried in this forever blown out white area. To photograph it so we see this, we have to blow that out. But eventually I'll work on getting a photo where I'm going to take something inside here and merge it with something outside here so we actually get a even tone across the nebula. But look at this stuff. It almost looks like a painting, doesn't it? Almost looks like just a painting. Look at this little ribbon right here. I'd like to sit outside I'd like to sit right outside this ribbon in my spaceship and go around it. This is going to be, this is like just about a light year long anyway, maybe a little less. That's a huge amount. You wouldn't even see this if you're sitting next to it. Wow, look at this. So much detail in this nebula. So much incredible detail. And back up to the Running Man. Getting even more detail in there. I think we can support 100% now. Wow. You can see that this is actually reflecting a subtle light from down below. Just beautiful.
I don't remember seeing red in the Running Man before.
Yeah, actually, there is red in there. That's probably... when I take the pictures here, you see some red over here. You don't really see the red down here. But it is there. It is there. I think what I have to do is do another color. I want to actually correct the colors, which is kind of hard for this thing because there's so many different colors. Wow.
If you look at a deep exposure of the constellation Orion, like that one Mark put up earlier, and you look at Barnard's Loop, the big red semicircle over on the east side of the constellation, you'll see that if you think supernova remnant, which is what the Barnard's Loop is, it pretty much centers right on the Orion Nebula, where stars have been cooking off in there in the past, and where the Barnard Loop is a shock run of a supernova a long time ago.
Yeah.
Somewhere down in the center of the molecular cloud.
Yeah. You're right about that. And notice, by the way, how our satellite trails are getting more and more wiped out because they're being replaced subtly by the background. I tell you, this is like a painting. This one you want to see in the wall, like 6 feet tall.
Yeah.
Wow. Okay. I'm gonna have to call it here at 17 frames. So we're gonna pause. We're gonna save this. Isabella's going, yeah. And then save exactly as seen. Wow. Oh, I'm telling you, this is just stunning.
Well said, Isabella.
Oh, yeah. She says, looks like the paintings of the Sistine Chapel. You know it's a bright nebula. You know it's a bright nebula when even at your lowest exposure, that's not my lowest, it can go a lot smaller than that, it's overexposed in the center. Wow. Well, guys, this is great. I really enjoyed your company tonight. Had a good time. And I can't stay up any longer. If I could stay up all night, we would be up longer enough to see the Rosette, Thor's helmet, and a lot of the others that are just tantalizingly out of reach right now. We're reaching for this right now. But we'll be back to this. That's a promise. So step 1 here, I will shut down my focusing system. What's the temperature out there now? Let's see. Temperature is 65. It's gone down several degrees. It's gone down 4 degrees since we started. That's been enough to change the focus. Okay. And then we can get rid of this. This is our planetarium hook. We're going to say that's done. And then we'll exit this. Oh my gosh, it's just beautiful. Wow. Amazing. Now we can get rid of this. Okay. And then I believe we are ready to shut down. And now what we're going to do is we're going to park the telescope, which will park it in a predetermined spot that is used to give us a good starting point that it knows and remembers. You'll see the telescope moving to that parking position now. It says parking scope slewing right there. Okay, and then it's going to say scope is parked, shut off the scope. And there it is. So the scope is now parked. I now shut off the scope over here. And that's that. And now we're done. And I can get out of this camera. I did not have this camera when I started up, so I actually rebooted the computer and it was there. So that was pretty interesting. Okay.
Another great stream, Mark. Thanks for having me on.
Oh, of course. It's so much fun, going through all this stuff, and it's fun to have you. It's fun to have you here. Really good, and we had Marianne too, so we'll just have to, tell her that she missed the most incredible stuff.
Mhm.
Okay. Okay, and now, as a last step, besides the spider webs that we see there, I'm going to shut the roof. So there we go. And now the roof will close out there. Good night, telescope. Good night. Have a pleasant tomorrow. That's really awesome. And this building has room for 2 more telescopes, by the way, of this kind. If you want to put one with a German equatorial mount, that's going to mean that there's room for 1 more scope in here. Yeah. And this scope is going to go on a lifting column, which I'm about to buy. And that means that if the telescope is sitting where it is, you notice how it's below the level of the walls? Well, the lifting column is going to bring it up higher in the air so we can look right to the horizon. So we'll be able to see things that are just rising or just setting. And that's usually a bad place to look anyway. But for the skies out there, for the sky quality out there, it is stunning. So it's really not a big deal. We can still do it. So that's done there. And this is done there. I'll tell you, guys are great. I want to thank you so much for your attention tonight. And thank you very much for taking the time to come out here with us tonight. We had a great time. I'm B. And you know what? It was worth every bit of it. So I'm really happy that you could join us. And like I said, when you go out at night, don't forget, keep looking up. You know, and as Amanda would say if she was here, except while you're driving. So hope you guys have a good night. And we'll talk to you on the next stream.
We went over 5 hours.
No way.
Started about...
oh my gosh, I guess we did. I wasn't planning on going that long. I don't know why. It just... You know what? The night sky just turns me to hell on. What can I say? All right, guys.
Good night, everybody.
Well, you have a good night. We'll see you guys later.
Take care. Have fun. Be good.
You got it. And thank you, Daryl.
Sure.
We'll see you later.
Thanks for having me on.
Of course.